Before the function begins, I would like to draw your attention to the following points to be followed during the proceedings. Kindly keep your mobile phones switched off or in silent mode. No photography or video recording is permitted inside the auditorium during the function. All are requested to rise during the invocation and the national anthem. At the end of the function, please remain seated until the dignitaries leave the AMC auditorium. We will shortly begin the inaugural ceremony of Sree Chitra Conclave 2022, followed by the Parthasarathi Oration. All guests are kindly requested to be seated till the entire function is over. We have had an overwhelming response from delegates from across the country. Thank you for your participation. Kindly note that COVID protocols need to be followed during the proceedings for safety. This program is also projected in different halls and also live streamed via YouTube. May I have your attention, please? Our chief guest will now be entering the auditorium.
Ladies and gentlemen, a very good morning and a warm welcome to the inaugural ceremony of the Sree Chitra Conclave 2022 and the 5th G. Parthasarathi Oration. May I kindly request our Honorable Director, Professor Sanjay Bihari, to kindly lead the dignitaries to the stage. May I invite Shri V. Muralidharan, Honorable Minister of State for External Affairs and Parliamentary Affairs, Dr. Vijay Kumar Saraswat, member of Niti Aayog and Honorable President of SETIMST, Professor S. Chandrasekhar, Secretary, Department of Science and Technology, Government of India, Professor Atul Goyal, Director General of Health Services, Professor Ashutosh Sharma, former Secretary, Department of Science and Technology, Government of India, and Professor IIT Kanpur, and Sri C. Padmakumar, Special Officer, Kerala Medical Technology Consortium. I also request Professor Ajit Kumar VK, Dean, SETIMST, and Dr. Harikrishna Varma, Head Biomedical Technology Wing, and Dr. C. Keshavdas, Deputy Director of SETIMST, to kindly join the dignitaries on the dais. To begin this auspicious ceremony, may I kindly invite Dr. Anjani Sree, to invoke the Almighty.
Pranamam, pranamam, pranamam. Sarvabhutahitaishini pranamam. Sargadhanya chaitanyame pranamam. Sarvabhutahitaishini pranamam. Sargadhanya chaitanyame pranamam. Pranamam Guru Bhutare, pranamam Pitratulyare, pranamam Guru Bhutare, pranamam Pitratulyare, pranamam Priyatolare, pranamam, pranamam, pranamam. Jadi dvesha varga chindatan andya bodhatiluni sneha jyotis pulartidum bhuvanattilekku nayikkane, sneha jyotis pulartidum bhuvanattilekku nayikkane. Pranamam Guru Bhutare, pranamam Pitratulyare, pranamam Priyatolare, pranamam, pranamam, pranamam.
May I now request our Honorable Director, Professor Sanjay Bihari, to kindly welcome the gathering.
Good morning. Respected Shri Muralidharanji, Minister of State for External Affairs and Parliamentary Affairs, Padma Bhushan, Dr. V.K. Saraswat, Member Niti Aayog and President SETIMST, Professor Chandrasekhar, Secretary, Department of Science and Technology, Government of India, former Director, Indian Institute of Chemical Technology, Hyderabad, Professor Atul Goyal, Director General of Health Services, Government of India, and Director Professor of Medicine, Ram Manohar Lohia of Institute of Medical Sciences, New Delhi, Professor Ashutosh Sharma, our G. Parthasarathi Orator, former Secretary, Department of Science and Technology, Government of India, and Professor, Department of Chemical Engineering, IIT Kanpur, Mr. Padma Kumar, Director, Kerala Life Sciences Park and Chairman and Managing Director of Thirumu Pen Paul Limited, Professor Ajit Kumar, Dean of Medical Faculty and Professor of Cardiology, SETIMST, Professor Harikrishna Varma, Head Biomedical Technology Wing and Professor of Biomaterials at SETIMST, Professor Keshav Das, Deputy Director and Professor of Imaging Sciences and Intervention Radiology, SETIMST. The Honorable Chairman and Faculty of Sessions of Sree Chitra Conclave, respected dignitaries, august participants, guests, the Sree Chitra fraternity, and members of the press. I warmly welcome you to the beautiful state of Kerala and to our home SCTMST Trivandrum for the Sree Chitra Conclave 2022. Sree Chitra Institute of Medical Sciences and Technology is an institute of national importance under the Department of Science and Technology, Government of India, initiated by an Act of Parliament in 1980. The joint culture of medicine and technology that the institute pioneered more than 4 decades ago has come of age and has gained unprecedented acceptance in India. It is now my honor and proud privilege to felicitate our honored guests on the dais. Shri Muralidharanji, despite his very busy schedule and immense national responsibilities, has always been only a phone call away in extending his valuable support and immense help to our institute. And the action is so silently and elegantly performed that very few of our fraternity are even aware of it. Thank you so much, sir. Padma Bhushan Dr. V.K. Saraswat, one of India's most distinguished scientists in liquid propulsion system, has guided the destiny of our institute for a considerable time. I have come to realize how valuable and incisive his decisions are. I am simply amazed by his good nature and his innate desire to help as many people as he possibly can. This desire comes so spontaneously to him that I am simply wonderstruck. Thank you so much, sir, for guiding us. Shri Shivan Kuttiji, Minister of Education, and Shri Shashvu Tarurji could not join us at the last minute because of pressing engagements, and I am grateful to them for their very kind support and help. Professor Veena George, who also at the last minute could not come, has been one of the most inspiring persons that I have met since I took charge. Her evolution from being a professor of physics to a leading media journalist to heading the state health machinery in one of the most well-developed health systems of India, her equanimity in the presence of adversity, and her close association with our institute are extremely inspiring. Thank you so much, ma'am, for, she sent a message and I think it will be read out. Professor Chandrasekhar guides the destiny of our institute. Ever since he has taken over the helm of affairs at DST, he's only a phone call away and has strived to maximize the potentialities of our institute. I am grateful to him for his kind support, his accessibility, and his unwavering desire to carry our institute to greater heights. Thank you so much, sir. Professor Atul Goyal has been a valuable friend of the institute. Despite his immense national responsibilities and international stature, his humility and his ability to form teams and collaborations are valuable life lessons. You cannot imagine how deeply he cares about our institute and how many efforts he's making to enhance its stature. I'm grateful to him, sir. We are immensely honored to have Professor Ashutosh Sharma deliver the prestigious G. Parthasarathi Oration. As Secretary of DST during the turbulent times of the pandemic, his rock-like support for our institute, the clarity of his thoughts, and his immense ethical values have made an immense contribution to our rising in the NIRF ranking to 9th in the country. Considering the smaller size of our institute compared to all other institutes of national importance, this is no mean feat. He has also immensely contributed to the new hospital block and the combinational devices block, which will perhaps make SCTMST one of the largest institutes focusing on cardiac, neuro, and allied sciences in the country. Thank you so much, sir, for your contributions. This conclave would not have been possible without the immense role played by Mr. Padma Kumar, the co-organizer of this conference. Despite his extremely distinguished achievements in the field of technology translation, where he with his brother Mr. Balagopal have made SCTMST research product of blood bags into one of the most successful indigenous products of India, and his immense responsibilities in the field of Kerala as director of one of the emerging parks, he maintains an extremely low profile. I am grateful to him for all his guidance and support. Professor Ajit, Professor Verma, Professor Keshav Das, as well as Professor Mohanan and Professor Muralidharan, the organizers of this conclave, I have no words to thank you. I am grateful to you for a constant words of advice and enthusiastic help. I would be failing in my duties if I do not name the other distinguished faculty who are participating in the conclave, whose names figure amongst the who's who of India and the world. Shri Rajesh Pathak, Secretary Technology Development Board, Professor K.M. Ibrahim, Chief Principal Secretary of Chief Minister of Kerala, Mr. Suman Billa, Principal Secretary Industries, Dr. Uni Krishnan, Director KSIDC, Professor Kotnala, Chairman NABL, Professor Asim Sahu, Deputy Director, Drug Controller General of India, Professor Mohan Kunamal, Vice Chancellor, Kerala University of Health Sciences, Professor Satish Chandra, eminent neurologist and former Director, NIMHANS Bangalore, Professor Manoranjan Mohanty, in charge of Autonomous Institute Division, Department of Science and Technology, Professor Preeti Chauhan, Professor Biochemistry, Lady Harding Medical College, Professor Madhuri, Professor of Pediatric Orthopedics, CMC Vellore, Professor Renu John, Professor and Head Department of Biomedical Engineering, IIT Hyderabad, Professor Singaram, in charge Medical Incubation, IIT Madras, Professor Ravi Kumar, retired Director JIPMER, Vice Chancellor, Sri Venkateshwara Institute of Medical Sciences, and President AIMS Mangalgiri. Professor Ravi, Professor of Mechanical Engineering, IIT Mumbai. Professor George Thomas, Professor of Chemistry, Indian Institute of Science, Education and Research, Trivandrum. Professor Joseph Kuruvilla, Distinguished Professor and Dean, Indian Institute of Space Technology, Trivandrum. Professor Ajit Behel, Professor of Cardiology, PGI Chandigarh. Mr. Thomas John, CEO, Agape Industry. And Dr. Lini Basil from Biolin Meditech. 4 of my dear friends from neurosurgery, Professor S.K. Gupta, Professor and Head, PGI Chandigarh, Professor Shashank Kale, Professor and Head, AIMS New Delhi, Professor Malla Bhaskar Rao, Professor and former Head, NIMHANS, and Brigadier Swami, Head of Super Speciality Hospital, Jabalpur, are also here to grace the occasion. I am grateful to all these illustrious guests for their contribution. We also have Professor K.J. Joseph from the Gulati, Director of Gulati Institute of Finance and Taxation, and Mr. B.G. George, CMD of HHL Limited here. Thank you so much for coming here. I'm grateful for them. The amazing spirit of the fraternity of SCTMST, the value of deep caring and generosity for the less fortunate, and the abundant focus of innovation and interdisciplinary cooperation. These are inculcated from the inception of the training here. And this is what makes this institution so special. May this last forever. I hope that the Sree Chitra Conclave 2022 will be able to disseminate the spirit of cooperation and endeavor that will help all the citizens of India, and especially the unfortunate ones. Thank you very much for.
Thank you, sir. May I now request Dr. Vijay Kumar Saraswat, Member of Niti Aayog and Honorable President of our Institute, to kindly address the gathering.
Namaskar, good morning. Honorable Minister of State for External Affairs and Parliamentary Affairs, Shri Muralidharan ji, Professor Chandrasekhar, Secretary DST, Professor Atul Goyal, Director General of Health Services, Government of India, Professor Ashutosh Sharma, Shri Padam Kumar ji, Professor Ajit Kumar, Professor Keshav Das, H.K. Verma, and leading all of this is our beloved director today, Professor Sanjay Bihari, and all the esteemed dignitaries from different institutions who have come here to attend this seminar. It's a fantastic gathering, I must say. The kind of interest which has been shown is exemplary. It only speaks volumes as far as the reputation of the work which is being done in Sree Chitra Institute of Technology and Science and Technology. It is fantastic. I've been given the task of extending a warm welcome and also give a presidential address. Actually, your benign presence here has served to enhance the prestige of our institute. The enthusiastic response is a testimony to the hard work contributed by all members of the institute. It is also an offshoot of the wonderful cooperation that exists between Sree Chitra, Department of Science and Technology, Department of Health and Family Welfare, Government of India, as well as the Government of Kerala. Our institute is just over 4 decades old. Despite its short period of existence, it has generated considerable impact on the national scene in the arena of advanced clinical care, biomedical engineering and technology, as well as public health sciences. Despite its smaller size compared to the other institutions of national importance and its focused domains in the arena of cardiac and neurosciences, the achievements and efforts of the institute are well exemplified in its upholding the NRF ranking of 9th this year among all medical institutes of the country. We should give a big hand for that. The institute has been responsible for the emergence of several commercially competent technologies. In 2001, it won the prestigious National Technology Award for the successful development and commercialization of the artificial valve. Many products based on the know-how developed in this institute are now being exported, including to the developed countries. The current annual requirement of medical devices in India is worth about rupees 30,000 crores. Of this, only 20% products are produced indigenously. If our country is to be less dependent on imported products, then the Indian medical device industry must considerably expand. This clarion call for a holistic approach to medical device development from the government is an offshoot of the wonderful initiative of Atmanirbhar Bharat of the Honorable Prime Minister of India. Based on this approach, the public-funded institutions like ours have felt the need to take up the role of facilitator and a catalyst in promoting industrial growth. This will go a long way in helping to bridge the gap that exists today in the development of indigenously produced medical device technology. This approach has also been proposed by this institute through its Vision 2020 and Vision 2030 programs that have been aimed at promoting the Indian medical device industry to global levels. This will go a long way in helping to bridge the gap that exists today in the development of indigenously produced medical device technology. This approach has also been, none of this is possible without the close cooperation between the academic institutes, the hospitals, the industry and the administrators, all of whom should work together towards the goal of medical technology development. The presence of so many leaders in this field in Sree Chitra Conclave 2022 is a testimony to the fact that there is now an increasing awareness of the need to cooperate at the ground level. This conclave will in a small way help in enhancing this cooperation. Following good health practices by doctors, nurses, technicians, and ancillary staff, an intrinsic component of the character of hospital wing of the Sree Chitra Institute, a demand is generated for good medical devices. This in turn is supported by both an intellectual input from the biomedical technology wing of the institute, the industry, and the financial and manpower input from the administrators. The spirit of cooperation and interdependence is an essential feature of our institute that is now being emulated by several medical, engineering, and scientific institutions across the country. To achieve global competence, the industry should work towards knowledge-based growth, characterized by its ability to create wealth from the knowledge. It should be able to meet global standards in the development of kits, products, and services. It was in this context that our institute also started its efforts to obtain globally acceptable quality systems for its testing services so that its industrial partners and clients could use the test results for a product verification abroad, like CE marking and US FDA approval. This effort became successful in 2003 when the Le Comité Franquet d'Accreditation, that is COFRAC of France, a founding member of the International Laboratory Accreditation Corporation, it is also called ILAC, ILAC, certified the institute testing services. Since then, almost all major medical device industries in India have been beneficiaries of the institute's testing services. The institute holds innumerable medical innovation awards and more than 150 national and international patents. The patent to commercialization ratio is close to 25%, which ranks among the best translational standards in India. The institute had set up entities like the Technology Proving Facility to smoothen the scaling up process during the transfer of know-how to the industry. The extension of this endeavor is a well-functioning technology business incubator, TIMED, that encourages several startup companies to showcase their products. The institute has also established a technology research center for biomedical devices as part of the 5 center established by the Department of Science and Technology that has been set up nationwide in the specialized areas of science and technology. This facility was able to transfer more than 10 technologies to the industry. The intervention of the Technology Research Center during the COVID-19 period was quite remarkable, and with the help of industrial partners, was able to bring out many products to the market. The newly developed combination device block, as mentioned by our dear director, that will soon be inaugurated, will further enhance the concept of interdisciplinary cooperation. I extend my warm welcome to all of you to Sree Chitra Conclave 2022. This meeting is attempting to bring together professionals from the clinical community, industry, regulatory bodies, and research and development institutions on a single platform. It is seeking the way forward to combat the challenge being faced by the healthcare technology segment in the country from the combined perspective of the medical end user, manufacturers, administrator, and regulator. It's a very important occasion because while working from Niti Aayog, even before I took over as the president of Sree Chitra, there was a major focus on development of medical devices. And we found that the whole process of development of medical devices in the country was plagued with many roadblocks, particularly regulatory, some policy, infrastructure issues, and many things which are related to what we call the synergistic approach to achieving the best as far as this particular segment is concerned. So when I came here as a president, and I saw the activities of the biomedical technology wing, I was really very happy that at least there is a center where there is a focused approach for development of the medical devices. And then we also started interacting with other institutions like the center what Professor Ravi in IIT Bombay is heading, and the work which is being done as the Visakhapatnam Medical AP MTZ zone, and many of them which are now coming up. It's a good sign that the awareness has happened, and I'm sure this conclave will further this awareness and bring all of you together. I wish this conclave my very best wishes. May it ignite young minds towards a focused and amalgamated approach to the field of biomedical technology development. Thank you very much. Namaskar.
Thank you, sir. May I now request our chief guest, Sri V. Muralidharan, Honorable Minister of State for External Affairs and Parliamentary Affairs, to formally inaugurate the Sree Chitra Conclave 2022 and to kindly address the gathering.
The president of today's inaugural ceremony of the Sree Chitra Conclave, Dr. V.K. Saraswat, Professor S. Chandrasekhar, Secretary, Department of Science and Technology, Government of India, Professor Atul Goyal, Director General of Health Services, Government of India, Professor Sanjay Bihari, Director of Sree Chitra Tirunal Institute of Medical Science and Technology, Sri Padma Kumar, Special Officer, Kerala Medical Technology Consortium, Professor Ajit Kumar, VK, Dean, Professor Keshavadas, Deputy Director, Professor H.K. Verma, Hari Krishna Verma, Head BMT Wing of the Science and Technology, Sree Chitra Tirunal Institute of Medical Science and Technology, Professor Ashutosh Sharma, who will be delivering the Parthasarathi Oration, former Secretary of DST and Professor IIT Kanpur, other dignitaries who are present here, participants of this conclave, two-day conclave, friends from the media, other invitees, namaskaram to all of you. I feel delighted to be here at this prestigious Sree Chitra Tirunal Institute for Medical Sciences and Technology, an institution of national importance under the Department of Science and Technology, Government of India. I know that the institute has been providing high quality advanced treatment of cardiac and neurological disorders and also paving the way for indigenous development of technologies for biomedical devices and materials and public health training and research. Let me take this opportunity to congratulate the medical fraternity for their invaluable contributions to the medical field and for serving the people, not only in Kerala or Thiruvananthapuram, but from far and wide, people have been approaching and consulting this prestigious institute for their problems. This institute has excellent facilities and dedicated teams of professionals who are involved in the development of innovative biomedical devices and products, evaluation of medical devices, and research in medical and public health areas. It's the pride of Kerala and at the same time the pride of India. Let me again express my special appreciation for bringing all the professionals and experts on a single platform to address the challenges faced by healthcare technology and provide suggestions to overcome them. As you all are aware, India has showcased its capacity and scalability when forced by the challenges of COVID-19. If you recall, at the start of the pandemic, there was a global shortage of all kinds of medical equipment, including N95 masks, PPE kits, ventilators, etc. most of the products were not being manufactured in the country. We were dependent on many necessary healthcare components and medical devices from abroad. Turning the pandemic into an opportunity, Prime Minister Sri Narendra Modi ji decided to turn the tide. And with the combined efforts of the Health Ministry, various other partners like the textile industry, the pharmaceuticals, DRDO, many others, India has hugely ramped up its own manufacturing capacity. It is the spirit of Make in India embedded in the Atmanirbhar Bharat Abhiyan. Between March to August 2020, the states procured 1.40 crore indigenous PPEs and the center distributed 1 crore 28 lakh PPEs free of cost. Domestic production capacity strengthened to such a level that the Director General of Foreign Trade permitted the export of PPEs, and India started exporting and could export almost 23 lakh PPEs abroad, including to the so-called developed nations like USA, UK, and many others. This has substantially aided India to a position to position itself in the global export of market of PPEs. ഏത് പ്രതിസന്ധിയിലും അവസരത്തിന് തുയരാൻ ഇന്ത്യൻ ആരോഗ്യ മേഖലയ്ക്ക് കഴിയും എന്ന് തെളിയിച്ച അവസരമാണ് COVID-19. പ്രധാനമന്ത്രി മുന്നോട്ട് വെച്ച ആത്മനിർഭർ ഭാരത്, ആത്മനിർഭരത, സ്വാശ്രയ ഇന്ത്യ എന്ന ആശയത്തെ ആദ്യം പ്രാവർത്തികമാക്കി കാണിച്ച മേഖലയാണ് ആരോഗ്യ മേഖല. ഞാൻ നേരത്തെ സൂചിപ്പിച്ചതുപോലെ ഒരുപക്ഷെ കോവിഡിൻ്റെ പ്രാരംഭഘട്ടത്തിൽ ഇന്ത്യ പരിപൂർണമായും ഈ മേഖലയിൽ അതിൻ്റെ ഏറ്റവും പ്രാരംഭ ദശയിൽ നിന്നിരുന്ന ഒരു സാഹചര്യത്തിൽ നിന്ന് ലോകത്തിലെ ഏറ്റവും വികസിതമായിട്ടുള്ള രാജ്യങ്ങളിലേക്കടക്കം PPE കിറ്റുകൾ കയറ്റി അയക്കുന്ന സ്ഥിതിയിലേക്ക് വളരാൻ, പുരോഗതി പ്രാപിക്കാൻ നമുക്ക് സാധിച്ചു. അതിൽ തന്നെ ഞാൻ ഓർക്കുന്നു, ശ്രീ ചിത്ര വികസിപ്പിച്ച PAPR, പ്യൂരിഫയിങ് റെസിപ്പിറേറ്റർ കിറ്റ്, ഈ കിറ്റുകൾ ആരോഗ്യ പ്രവർത്തകർക്ക് വലിയ ആശ്വാസം നൽകി എന്നുള്ളതാണ് ഞാൻ മനസ്സിലാക്കുന്നത്. അതുപോലെ കുറഞ്ഞ ചെലവിൽ വേഗത്തിൽ ടെസ്റ്റ് റിസൾട്ട് കിട്ടുന്ന ടെസ്റ്റ് കിറ്റ് ശ്രീ ചിത്ര വികസിപ്പിക്കുകയുണ്ടായി. അങ്ങനെ സ്വാശ്രയത്വത്തിൻ്റെ മാതൃകകൾ ഈ രാജ്യത്തിൻ്റെ മുന്നിൽ അവതരിപ്പിച്ച സ്ഥാപനമാണ് ശ്രീ ചിത്ര എന്ന് പറയാൻ എനിക്ക് ഏറെ സന്തോഷവും അഭിമാനവുമുണ്ട്. ആരോഗ്യ മേഖലയിൽ, പ്രത്യേകിച്ച് ആരോഗ്യ ഉൽപ്പന്നങ്ങളുടെ നിർമ്മാണ മേഖലയിൽ രാജ്യം സ്വയം പര്യാപ്തത കൈവരിക്കുക എന്നുള്ളതാണ് നരേന്ദ്രമോദി സർക്കാരിൻ്റെ ലക്ഷ്യം. മേക്ക് ഇൻ ഇന്ത്യ പദ്ധതിയുടെ ഭാഗമായി മെഡിക്കൽ ഉപകരണ നിർമ്മാണ പാർക്കുകൾക്ക് കേരളത്തിലടക്കം കേന്ദ്രം അനുമതി നൽകിയത് ഈ ലക്ഷ്യത്തോടുകൂടിയാണ്. ലോകോത്തര നിലവാരത്തിലുള്ള മെഡിക്കൽ ഉപകരണങ്ങൾ ഇതിലൂടെ ലഭ്യമാക്കാൻ നമുക്ക് സാധിക്കും. ഏഷ്യയിൽ മെഡിക്കൽ ഉപകരണങ്ങളുടെ ഏറ്റവും വലിയ വിപണികളിൽ ഒന്നാണ് ഇന്ത്യ എന്നത് നമ്മുടെ സാധ്യതകൾ വർദ്ധിപ്പിക്കുകയാണ്. ലോകത്ത് അതിവേഗം വളരുന്ന മെഡിക്കൽ ഉൽപ്പന്ന നിർമ്മാണ മേഖല കീഴടക്കാൻ നമുക്ക് കഴിയും എന്നുള്ള കാര്യത്തിലും ഒരു സംശയവുമില്ല. ശ്രീ ചിത്ര പോലെയുള്ള സ്ഥാപനത്തിന് ഈ രംഗത്ത് രാജ്യത്തെ നയിക്കാൻ തന്നെ സാധിക്കും. സ്വാതന്ത്ര്യത്തിന് മുൻപ് തന്നെ മഹത്തായിട്ടുള്ള ഒരു ആരോഗ്യ പരിപാലന പാരമ്പര്യം പേറുന്ന തിരുവിതാംകൂറിൻ്റെ മണ്ണിൽ നിലകൊള്ളുന്ന ഈ സ്ഥാപനത്തിൻ്റെ സാധ്യതകളെ പറ്റിയിട്ട് ഈ മേഖലയിലുള്ളവർക്കോ അല്ലെങ്കിൽ ഈ പ്രദേശത്തുള്ളവർക്ക് മാത്രമല്ല, ഈ രാജ്യം മുഴുവനുള്ള ആളുകൾക്ക് പോലും ഒരു സംശയവും ഉണ്ടാവില്ല എന്നുള്ളത് കൂടി ഞാൻ ഈ അവസരത്തിൽ പറയാൻ ആഗ്രഹിക്കുക. ഫ്രണ്ട്സ്, be it bandaging a sprained ankle, performing a surgery, or implanting an artificial hip, medical devices are central to healthcare. The cost of their manufacturing or import has a bearing on people's healthcare expenditure. access to good quality, affordable, and appropriate health products is indispensable to advancing universal health coverage. In this context, let me take this opportunity on behalf of the Government of India to appreciate this institute and the attendees from the medical devices industry, scientists, researchers, and students for envisioning a target that benefits the nation. I am aware that of your vision of 2047 is in line and in sync with the vision of the government, which is to make quality healthcare accessible and affordable to all. Friends, the medical device industry is a multidisciplinary sector. It has electronic equipments, implants, consumables and disposables, surgical instruments and in vitro diagnostic reagents. It's huge. Like its vastness, it has huge scope to grow. India is the fourth largest Asian medical devices market after Japan, China, and South Korea, and among the top 20 medical devices market globally. The Government of India is focusing on further boosting India's strength of skilled manpower, ease of business through various industry-friendly rules. As you all are aware, the current market size of the medical devices sector in India is estimated to be almost $11 billion, and its share in the global medical device market is estimated to be about 1.5%. But thanks to the initiatives such as the PLI and the focused approach of the Government of India, this industry is expected to grow fast at the pace of 28% each year to reach the 50 billion mark by 2030. Under Prime Minister Narendra Modi's leadership, healthcare has become more focused on innovation and technology over the past few years, especially post-COVID. And 80% of healthcare systems are aiming to increase their investment in digital healthcare tools in the coming 5 years. In the Union Budget of 22-23, 86,200 crores was allocated as budget for the pharmaceutical and healthcare sector. The Narendra Modi government launched a scheme for the promotion of medical device parks and is providing financial assistance for common infrastructure facilities in 4 medical device parks in partnership with the states. This measure is expected to reduce the manufacturing cost of medical devices in the country. To boost the domestic manufacturing of medical devices, a production-linked incentive, that's the PLI scheme, with an allocation of 3,420 crores, is also launched by the Government of India. Apart from boosting domestic manufacturing and attracting large investments in the medical device sector, this initiative is projected to result in an incremental production of almost 65,000 crores worth of materials over a period of 5 years. Definitely, this will lead to a substantial reduction in the import of target segments of medical devices and generate employment for around 40,000 persons. The export of medical devices from India stood at 2.53 billion in the financial year 21. But thanks to the Government of India's vision, this is expected to rise to around 10 billion by 2025. Friends, we are celebrating the 75th year of India's independence, Azadi Ka Amrit Mahotsav. And this crucial juncture, the Prime Minister has given a clarion call to make India into a developed nation by the year we celebrate the centenary of India's independence, that is 2047. And when India celebrates the centenary of India's independence, we would like to have a healthy, wealthy, and self-reliant India. From a country which is considered to be a low income country or somewhere around that. We would like to grow to a high income country by 2047, which many of you, if somebody feels that has any doubt about that, look at the experiences of surrounding countries around us, be it Japan, be it Korea, be it Singapore, be it China. They have all done it in a span of 10 to 17 years. And if they could do it in 10 to 17 years, there is no doubt that India can definitely have that achievement by the year when we celebrate the 100 years of independence. And this, in that spirit, the government of India has commenced various initiatives to strengthen the medical devices sector. It's building an ecosystem of innovation in medical devices and drugs, thereby enhancing the industry-academia linkages to a greater extent. Keeping the needs of the common man in mind, the government of India has taken measures to reduce its financial burden and spend on healthcare. The first step was the Ayushman Bharat scheme, equipping the common man, the poor and the downtrodden, so that he can avail good quality medical services. The second step was to provide generic medicines at affordable prices. In Kerala, around 980 Jan Aushadhi Kendras have been set up, and over 2,540 health and wellness centers are taking care of the health needs of the people of Kerala. I would also like to mention that under the Pradhan Mantri Jan Arogya Yojana, 68.32 lakh have received benefits in Kerala. I am aware of the vision of the medical devices industry for 2047, and that this conclave, which is basically to discuss various issues related to that, I am sure that this conclave will contribute in providing these solutions, suggestions, improvements that has to be made in this sector. I am sure the senior authorities from the government of India who are present here, who will be part of your discussions, they are here because government of India is receptive to each and every section of the country. And as learned medical professionals, scientists and researchers, your inputs and feedbacks are valuable, especially to see India as a global leader. Let's align our vision for 2047, as the Prime Minister gave the call, that the next 25 years, which is the transformative period of India, where the 25 years from a country which has, of course, we have progressed a lot from 1947 to 2022. But we are yet to progress. We have much more to progress, much more to travel. If we have to realize the dreams, the vision of those who laid down their lives for gaining independence of this country, for this country. If that has to be realized, and to realize that, we need to work together. It's not the efforts of the government only. That's why he said that when Prime Minister Narendra Modi came to power, he said that this government works with the motto of Sabka Saath, Sabka Vikas, Sabka Vishwas. But now, if India has to grow into a global leader, India has to achieve the target of a developed India by 2047. The efforts of everyone is required. That's why he said that I would like to add, with Sabka Saath, Sabka Vikas, Sabka Vishwas, I would like to add two more sentences, that is two more words, that is Sabka Prayas. That is efforts of all. So that efforts of all, let us work as a team to transform India into a global hub for manufacturing, quality and cost-effective, life-saving medical devices and equipments by 2047. Before concluding, let me extend once again my special appreciation to the organizers of the Chitra Conclave 2022, bringing doctors, scientists, medical professionals from the clinical community, industry, regulatory bodies, and R&D institutions. It's an extraordinary effort. You deserve all the applause for it. As a native of Thiruvananthapuram, I join the audience in lauding your efforts. This was timely and most relevant. Namaskaram to all of you.
Thank you, sir, for your inspiring words. May we request our esteemed chief guest, Honorable Minister Sri V. Muralidharan, to kindly release the souvenir of the Sree Chitra Conclave.
Thank you, sir, and all esteemed dignitaries. May I now request Professor S. Chandrasekhar, former Secretary, Department of Science and Technology, Government of India, to kindly address the gathering.
I apologize, not former, the present secretary. Will you former soon, don't worry.
Honorable Minister for State for External Affairs and Parliamentary Affairs, Sri Muralidharan ji, Saraswat ji, dignitaries on the dais, friends in the auditorium, greetings to all of you. It's an honor for DST to be part of this important event here to make sure that the Honorable Prime Minister's desire that India should be a leader in medical devices and Sree Chitra will be leading from the front. Congratulations to all the organizers who have taken efforts to make this event happen here today. As addressed by Saraswat ji and Honorable Minister, we are aware that the medical devices are going to play an important role in health for all. And certainly when we look at the FDA definition of what is a medical device, I'm told it can be found in the section 201H of the Federal Food and Drug Cosmetics Act. It's very broad. It basically says a medical device is any instrument, machine, contrivance, implant, in vitro reagent that's intended to treat, cure, prevent, mitigate, diagnose disease in a man. So that it clearly says that it covers everything which takes care of our health products. So while I would not like to reiterate on the statistics and what is that we need to do, I only would like to flag some issues which I'm sure this important delegates or as part of this event will deliberate in the next 2 days and come with some solutions. While I only recollect when Abdul Kalam ji and Somaraju from Hyderabad worked with this institute very closely, and those days we were fond of Raju Kalam stent, and we're all proud that India has made the first stent for the heart. But then one of the auto drivers whose father was undergoing a transplant, and when he went to the hospital and the doctors gave him two options. One was an imported stent which costed 1,40,000, another stent which is made by us for 40,000. Even when those medical insurances were not there, I'm talking of 30 years ago, 20 years ago, the auto driver said, I don't mind selling off my auto, but my father should have an imported valve. So this message to all of us is that sometimes the brand matters and how we are going to build the brand for all our products. I'm very happy that when Honorable Prime Minister addressed all of us during the CSIR Society meeting only 2 days ago, he has given a very important message to scientific fraternity that making a product is not difficult sometimes, but how you are going to compete not just by the cost. Many a times in the health sector, we don't mind if the cost is slightly higher because life is the most precious thing on this planet. We don't mind paying little more, but whether the product what we make competes the global standards and is it better. I think this forum also should debate on not that how we make them cheaper, but how we make the best. I think that's the motto of all of us, and I'm sure we'll work towards this important activity. As the definition says, starting from a tongue clip to a tooth clip for when we have upper teeth or the tooth are up, we use a small plastic clip, to invasive devices, to external devices. Today, even a mobile phone could be a device which could measure your blood pressure, which could measure many other things. And these devices and tools, what we develop, also need to have the global benchmarks. Many a times, all our doctor fraternity, while I'm not a medical doctor by training, but all of you would keep giving range of blood pressure or range of sugar levels or range of cholesterol levels or triglyceride levels. And if you use two different toolkits or you two different machines, it will give different numbers. So I think this standardization of our technologies is yet another important parameter. And who knows, a pre-diabetic is really a diabetic or not even a diabetic at all. And the numbers which are made for Western world, how relevant it is for our community. Can we really have a team which generates the data for all of us using artificial intelligence tools and other tools which are available today? Can we have Indian standards? Again, it reminds of Honorable Prime Minister who gave us a mandate how we could develop even footwear measurements which are exclusive for Indians. Because the footwear what we buy have numbers which are made by European standards or American standards. So certainly this is the forum where India occupies about 15 to 20% of the global population, and the standards what we develop have to be benchmarked for all of us rather than copying from elsewhere. Coming back to the materials what we use for these tools and devices, how Atmanirbhar we are. Again, Honorable Minister has given a clarion call through Prime Minister's discussion that how quickly India can become Atmanirbhar and how we are going to make our own materials. And that is where I think our chemical community, our material scientists are going to work very closely with the scientists working in the medical devices to make sure that we really reach those targets. We're all proud that India is a young nation, and as our Prime Minister advocates all of us, and our Minister, Honorable Minister has also told by 2047, we wanted to be the best country in the world. We become the torchbearers of the world. But we also should keep in mind that today we are the young nation, but after 25 years, with the kind of technologies available today, affordable healthcare, the surgical tools, the precision medical care we all get, the vaccinations we have developed, we have shown to the world that India can make 200 crore doses of vaccines in less than a year. Everyone was thinking that India can make 10 lakh doses per month. Every year they can make 1 crore. India needs 100 years to vaccinate the entire country. We have shown to the world that we could do in 1 year, 200 crore doses. Again, the investment made by the government in many PSUs, many private sector. This is what made us today mask-free society. While some of you are wearing a mask, but where again, Honorable Ministers are talking of PPEs and masks and all that, we never had a proper method to measure whether the mask is really filtering the virus or not. So whatever mask was available in the market, we bought it, not knowing whether it is silver coated or whether it's able to filter the virus or not. But Sree Chitra and few institutes came forward and gave us some standards on how we work on. So standards are going to play a role. While India is a young nation today, maybe by 2047, India will not be a young nation. Because today with the kind of family population control whole world is working on, maybe by 2047, India's average will be much larger than what we are today. India may not be a young nation. Problems of young nation are different from problems of a geriatric nation. Today we see the problems of France, problems of Japan are very different from problems of China and India. So what kind of medical devices or tools we require in 2047? Maybe we need a better walking stick, maybe we need a better drug for Alzheimer's disease, or we need some devices to measure the brain, how many brain cells are alive or dead, or whether at what stage or Alzheimer's disease is set. Today we are worried about cancer, heart diseases, but this hospital, while we are also on the neurological challenges, I do believe that taking the research activities into neurological disorders, what measurements we need to do that we could really have next generation drugs and tools for central nervous system disorders. Again, we have seen the failure rates of CNS drugs is very low because we don't have proper even models to test chemicals which we make in the lab to discover drugs for CNS, Alzheimer's, Parkinson kind of diseases. So while the definition of a medical device is as broad as health sector or healthcare, I do believe that the forum here will keep debating on how we are going to address the future challenges. While today we have conquered the human heart, we have seen how a small accident happens or a big accident happens and a person at the verge of death, the heart is taken out and then airlifted or maybe drone lifted in 1 hour, 2 hours to the nearest hospital to give to someone to give the life. We have seen how a kidney has been transplanted by a drone or a helicopter or even an ambulance in 2 hours. I've seen how a heart was taken from Bangalore to Hyderabad in less than 6 hours by road. I think these are the kind of things we are talking of today, and we need more devices and more technologies, but more authentic and globally challenging, globally competitive, also India-made, the standards which are made by us, which world follows. I wish this conference all the best and looking forward to have these deliberations taken forward. Thank you. Jai Hind.
Thank you, sir. May I now request Professor Atul Goel, Director General of Health Services, Government of India, to kindly address the gathering.
Very good morning to all of you. I'm back to Trivandrum after 40 years, all because of Dr. Sanjay Bihari. So dignitaries on the dais, dignitaries off the dais, my colleagues and friends from Sree Chitra Institute. I will keep it very brief because I think we are running behind the schedule, one. And second, I have a meeting at about 11 o'clock with the center. So a lot has been discussed about technology industry. I hope people who are in medicine realize that we are in the 100th year of the discovery of insulin. Insulin was discovered in 1922. From 1922, when insulin was discovered, it took about 23 years for insulin to be commercialized for use in medicine, which means it started its use in 1945. Today we are in an era of healthcare industry which seems to be in a hurry. It seems to be in a hurry. And I would strike us some bit of caution. When we talk of healthcare industry, we must realize that medical sector or healthcare per se has two parts to it. One is the devices, the technology, and the other part is the service. And I think it's of immense importance in a country, in a populous country like India, where we'll soon outgrow China. And just by increasing the output from the healthcare industry, we are not going to take the healthcare needs of nation into our stride. We will have to also look at prevention. You know, they are like two parallel lines. In fact, railway lines, I would say, which are joined with wooden boards. So unless you reduce the burden of the disease, you are never going to take care of the healthcare industry by producing devices. But at the same time, we must also look at the fact that the Western world has increased the cost of the healthcare immensely. We often talk of percentage of the GDP as to be spent on healthcare. I think the cost needs to be reduced. And here is where innovation in an institute like Sree Chitra comes in. You lower down the cost at the same time, but look at prevention as well. And when we talk of holistic approach, we should talk of holistic approach to a lot of things. And for that matter, Sree Chitra has three parts. One is the hospital, the second is the technological aspect, and the third is one more institute, which is public health, which is part of the university. So that has to be taken into consideration, because that will be the interface between the doctors, the medical devices, and the public. Then we talk of Atmanirbhar Bharat. Honorable Minister talked of Atmanirbhar Bharat. We must remember, as a healthcare industry or as doctors, that generic medicines are equally effective, if not better than branded medicines. So as a healthcare professional, we must try and shift to generic brands of medicine that are being promoted, and there are good quality generic medicines as well. The second is another approach that the health ministry is coming up with, is in terms of Heal in India and Heal by India, which would be, again, Sree Chitra would play an important role in it. Then another word that India can add to the definition of health is spirituality. You see, the WHO talks about physical health, mental health. It doesn't, emotional health. It doesn't talk about spirituality as part of health. And unfortunately, some of us confuse spirituality with religion or religious practices. It's nothing to do with that. It's a sense of satisfaction and happiness that comes from within, which is extremely important in protecting one from disease, because a happy mind can only protect one from disease. Now, it has been often said by the Prime Minister, Honorable Prime Minister, that adversity becomes an opportunity. That was demonstrated in COVID. We talk of innovation. There have been, stories. Sree Chitra has been very prominent. There have been stories of production of ventilators in the idle Maruti factory at Delhi during the time the COVID was there. At the time when ventilators were short. Yes, they were not sophisticated, but they could take care of the basic life at that point of time. I hope we don't see the COVID era again, and we should get out of it. I wish this conclave great success, and I wish the energies and the enthusiasm of the current director, Dr. Sanjay Bihari, takes the institute to greater heights. Thank you.
Thank you, sir. May I now request Shri C. Padma Kumar, Special Officer, Kerala Medical Technology Consortium, to kindly address the gathering.
Honorable President Dr. Saraswat, Professor Chandrasekhar, Professor Atul Goyal, Professor Ashutosh Sharma, Dr. Bihari, Dr. Verma, and ladies and gentlemen, I'm going to keep my remarks very short. I actually have to say only very few things. I've been associated with this institution since I started my career. In 1985, right after business school, I joined a company called Peninsula Polymers Limited, also known as Penpol. And I finished my course in December. In January, I had the opportunity to go to the biomedical technology wing of the institute, and that was my introduction to medical devices and to this very fine institution. I'd like to place on record the thanks not only of my former company, Penpol initially, later Terumo Penpol. I notice some of my former colleagues are here in the audience. On behalf of our founder, Mr. Balagopal, I'd like to place on record our thanks to Sree Chitra Tirunal Institute for Medical Sciences and Technology, because without the institute, there would have been no Penpol. I would also like to thank the first director, Dr. Valiathan, Professor Ramani, Dr. S.N. Pal, and so many others of the Institute who actually helped to create this organization. Now, what is the result of the blood bag technology, which was the first technology developed by the institution? I think there's a big lesson in what happened in our case, not just for the medical device industry, but also for the government. So it's worth, actually, somebody should do probably a little bit of a case study. What started as a very small factory with 2 million blood bags capacity is now a huge factory. I'm talking about the Teromo Penpol factory. The capacity is currently 40 million bags a year, which is estimated to be something like 10% of the global capacity. What is even more impressive is not this one company's achievement. If you take all the capacities of the companies which have been licensed by Chitra and which use the Chitra technology, I estimate that 20%, 1/5 of the global blood supply is in Chitra blood bags, and that is no mean achievement. What the Chitra technology also did was to significantly reduce the price of blood bags, not just in India, but I think across the globe. So the Institute has a fabulous track record. It has got several very sophisticated instruments, devices like the artificial heart valve, the blood oxygenator, the cardiothoracic reservoir, the hydrocephalus shunt. I'm sure this is just the beginning. And we're very happy to be a part of this conference. I represent currently after retirement, and in what may seem a strange move, I now work for the government of Kerala, representing an organization called the Kerala Medical Technology Consortium. And our job is to try and make Kerala the medical device hub of the country. And I believe it is possible because we have an ace up our sleeve, and that is the finest biomedical research institution in this country, the Sree Chitra Institute for Medical Sciences and Technology. So thank you once again, Dr. Bihari, the entire team here at Chitra, and best wishes for the next 25 years. Thank you.
Thank you, sir. We will now be proceeding with the prestigious 5th G. Parthasarathi Oration. I request Professor Ajit Kumar, Dean SETMST, to kindly give an introduction on the G. Parthasarathi Oration.
Good morning, everybody. Honorable Minister Sree Muralidharan, President of the Institute, Dr. V.K. Saraswat, Professor S. Chandrasekhar, Secretary DST, Professor Atul Goel, DG Health Services, Professor Ashutosh Sharma, former Secretary DST, and Professor IIT Kanpur, Sri C. Padma Kumar, Special Officer, Kerala Medical Technology Consortium, Honorable Director Dr. Sanjay Bihari, Deputy Director Dr. Keshav Das, Head BMT Wing Dr. Verma, Institute Body Member Dr. Sen Kumar, distinguished guests, members of the faculty, students, and my dear friends. It is indeed a rare privilege and honor for me to address this august audience on this occasion of the Parthasarathi Oration. Beyond the pandemic, but still into the Ukraine war, humanity is still struggling to find peace and comfort. Despite all this in the background, our country in its 75th year of independence is moving forward, carving its own place in history. Now, what is Parthasarathi Oration? Any oration is a formal speech delivered in a dignified manner on a befitting occasion by a distinguished person. The Parthasarathi Oration was instituted in the year 2013. The former distinguished speakers who delivered the oration include Professor Farid Murad, Nobel Laureate, Professor C.N.R. Rao, Bharat Ratna recipient, Professor M.S. Velyathan, Founder Director and Padma Vibhushan recipient, Sri Subramaniam Ramadurai, former Vice Chairman and of the Tata Consultancy Services and Padma Bhushan recipient. Now, after a COVID break, the fifth Parthasarathi Oration today is Science and Scientists in the New Millennium, a short history of the future, will be delivered by Professor Dr. Ashutosh Sharma. The Parthasarathi Oration stands as a fitting testimonial to the administrative capabilities of Sri Gopalaswamy Parthasarathi. He was born in 1912, educated in Madras and Oxford, served as the Indian ambassador to Indonesia, China, United Nations, and Pakistan. And known as GP, Sri Parthasarathi was a brilliant diplomat and an intellectual par excellence. He was known for his skills as a skilled negotiator for India on many national and international issues. Apart from his diplomatic achievements, Sri Parthasarathi was a noted sportsman. He was the architect of the Jawaharlal Nehru University and chairman of the Indian Council of Social Research. As the first president of SCT-IMST, it will be sufficient to say that GP played a defining role in shaping the destiny of this institute during its early formative years. He passed away in 1995, and this GP oration is organized as a tribute to him. Professor Ashutosh Sharma, our former secretary DST, and Professor of IIT Kanpur is the most apt person to deliver this oration on the 75th year of independence. He has steered DST for the last 5 years, given it a sense of direction, and helped us, especially during the difficult COVID times. He will be introduced by the Deputy Director, Professor Keshava Das. Once again, I welcome the Honorable Minister, the dignitaries, invited guests, members of the faculty and students to this Parthasarathi oration. Thank you. Jai Hind.
Thank you, sir. I now request Professor Keshav Das, Deputy Director, SCT-IMST, to kindly introduce the speaker for the G. Parthasarathi oration.
Good morning to all. Honorable Minister, respected dignitaries on and off the dais. I am here to introduce our orator for the year 2022, Professor Ashutosh Sharma. Professor Ashutosh Sharma is a visionary academician who has made some exceptional interdisciplinary contributions in the nanoscience and nanotechnology fields. From 2015 to 2021, he served as the Secretary, Department of Science and Technology, Government of India. He is an Institute Chair Professor and C.V. Sheshadri Chair Professor at the Department of Chemical Engineering, Indian Institute of Technology, Kanpur. He is the founding coordinator of DST Thematic Unit of Excellence on Soft Nanofabrication and Chairman of Center of Environmental Science and Engineering at IIT Kanpur. Ashutosh Sharma got his B.Tech degree in Chemical Engineering from Indian Institute of Technology, Kanpur in 1982. Sharma graduated with a master's degree from Pennsylvania State University in 1984 and 3 years later obtained his PhD in Chemical Engineering from the State University of New York at Buffalo. For the next 3 years, he worked as a research scientist with the Department of Ophthalmology, School of Medicine and Biomedical Sciences, State University of New York. In 1991, he moved to India and joined IIT Kanpur in the Department of Chemical Engineering. Ashutosh has had a broad international experience as a visiting faculty at the University of Texas at Austin, the University of Western Ontario, the University of Erlangen-Nuremberg, and the world-class university program of South Korea, and as a member of the European Research Commission. Professor Ashutosh's research contributions are highly interdisciplinary, spanning a wide range in nanotechnology, thin polymer films, nanocomposites and devices in energy, health and environment, functional interfaces, micro and nanomechanics of soft matter, nanopatterning and nanofabrication, colloid and interfacial engineering, biomaterials and biosurfaces, wetting and adhesion. He has made original pioneering contributions to the understanding of the behavior of thin films and over highly confined nanoscale system. He has filed over 15 patents, given over 150 invited or keynote conference presentations, and mentored a nanotechnology startup. Professor Sharma has published more than 360 peer-reviewed research articles, has around 20,000 citations, an H index of 77. He has been on the editorial board of several reputed journals, which includes Chemical Engineering Science, Journal of Colloid and Interface Science, Nanomaterials and Energy Journal, Journal of Micro and Nano Manufacturing, ACS Applied Materials and Interface. As Secretary of Government of India, he helped initiate several new programs related to infrastructure and human capacity building, innovations and startups, R&D in advanced manufacturing, waste processing, clean energy and cyber physical systems, industry academia cooperation, science communication, women scientists, and major international collaborations in the area of priority for the nation. He is the recipient of the prestigious Shanti Swarup Bhatnagar Award in Engineering Sciences for his original pioneering contribution to the understanding of the behavior of the thin films and other highly confined nanoscale systems. He was selected as the president of the Indian National Science Academy in 2022. He is an elected fellow of prestigious societies such as the Academy of Sciences for the Developing World, the Indian National Academy of Engineering, the Indian Academy of Sciences, and the National Academy of Sciences, India. In 2017, he received UNESCO Medal for outstanding scientific contributions to the development of nanoscience and nanotechnologies. He was awarded Distinguished Alumnus Award from the Indian Institute of Technology, Kanpur, and the State University of New York, Buffalo. He is also the recipient of 2008 Toaz Prize of the World Academy of Sciences, Basel Research Award of the Humboldt Foundation, and the Homi J. Baba Award of the UGC, the Syed Hussain Zahir Medal and the Meghnad Saha Medal of INSA, J.C. Bose Fellowship, and in 2017 of the H.K. Firodia Award for his pioneering work on colloids, film interfaces, and adhesions. He received the MRSI Distinguished Lecturership Award from the Material Research Society of India in 2012. In the year 2010, Infosys Science Foundation awarded him with the Infosys Prize in Engineering and Computer Science for his scholarly scientific contributions in the broad areas of nanoscale surface pattern evolution, instability, and the dynamics of thin liquid and solid films and soft matter. Finally, I should not forget to mention that Professor Ashutosh's interests also include ancient history and philosophy, poetry, and art. Along with this introduction, I invite the Director, the Dean, and Head BMT Wing to join the felicitation of the orator.
I kindly request Professor Ajit Kumar BK, Dean SATIMST, to honor our esteemed orator, Professor Ashutosh Sharma, with a ponnada. Thank you, sir. I request our Honorable Director, Professor Sanjay Bihari, to present the citation certificate and a memento to Professor Ashutosh Sharma. Thank you, sir. May I now request Dr. Hari Krishna Verma, Head Biomedical Technology Wing, to kindly present a medal to Professor Ashutosh Sharma. Thank you, dignitaries. It was indeed a great moment. May I now kindly request the dignitaries on the dais to kindly be seated in the front row of the auditorium for the commencement of the oration.
I'm not running away.
Now I welcome Professor Ashutosh Sharma, Professor IIT Kanpur and former Secretary DST for the oration.
So while they are fiddling with the microphone, let me just start our conversation. I am so delighted to be here, and I'm so thankful to the director, Dr. Sanjay Bihari, for the invite. And I'm so happy to see, of course, that Dr. Chandrasekhar is here, Dr. Atul Goyal, all the distinguished faculty and staff and students of Sree Chitra, as well as speakers who have come from outside. Needless to say that I was very delighted to also receive all the honors that were there. I was just thinking only thing remaining is pouring water on me now there sitting. They would have completed the stuff. Okay, this is working now. Can we turn out these lights here? I mean, maybe 3 of these lights so you can see that better. Anybody can turn off these? Okay, great. Perfect. Right. So first of all, let me say, while this talk is not really about biomedical devices, a little bit of it, maybe 2 minutes, 2.5 minutes, which pretty much covers what the people already said, and all of you know much more about biomedical devices than I do. So what I would try to do is focus on some of the aspects of doing science, the architecture of doing science, the structure and the processes of doing science, which might be common to all kinds of scientists, regardless of who we are and what we do. Now, about the brief history of the future, people often ask me what that actually means. I'm not very sure what it means, but I just liked it. So I put it there, and hopefully that during the lecture, we would figure out that the history is as important as the present and the future, because it's the history that we build on. We are, of course, standing under the banner of a great person, and I dug up some information on him from, Google Guru that we all go to now to learn anything. And so what I learned here, that he was a journalist, he was an educationist, he was a cricketer. In fact, he led the Ranji team over several seasons, and he was a great diplomat. Of course, lateral entry as a diplomat. And then he was, of course, he did great things. He was the founder president of the institute. He was permanent representative to the UN, chairman of the Indian Council of Social Science Research. He was the first vice chancellor of JNU. And it's a small world because now Dr. Saraswat, of course, he's left now, but he is the chancellor, current chancellor of JNU. Ranji founded the Indian Institute of Mass Communication. He was chairman of the Policy Planning Committee in the Ministry of External Affairs. The rank, of course, is also important, but and many, many more things, because on one slide you can only put in 6 lines or something. So he was totally a polymath, and the reason that's important is I thought that this is a very good model for scientists of today and especially of tomorrow, because tomorrow is all about the convergence of different streams of knowledge which have been fragmented in so many different ways over 2 centuries of industrial revolutions, of the college education, university, the rise of universities, the mass education, the rise of that undergraduate education, which resulted in very great fragmentation of knowledge in million different compartments. So to bring them all together, to have a holistic perspective, to have a holistic approach to problem solving, it's a great model for that. So even though he may not have been a scientist, but everybody who has a scientific temper is actually a scientist. Often people confuse scientific temper with having a lot of degrees in science. Nothing could be farther from truth. So anyhow, that's a good, could be another discussion for a 10-hour long discussion, if you would. Okay, here is about the medtech market potential in India. This report is actually put together by Swiss Next in India. So they are looking for the opportunities for biomedical sector in India. And their projections are, of course, that this is a Swiss franc, which is about 80 rupees, just like a dollar, is about $50 billion worth of business in India. Interestingly, if you were to look at what are the different sectors that contribute to it, disposable and consumables, well, they are a little bit better because percent import is only 32% there. But if you were to look at electronics and equipment, surgical instruments, okay, here, well, that's not doing so well. Percent imports 87%. In vitro diagnostic and reagents, and well, that's not good either, 77%. And similarly, implants, about 80% are imported. Now, of course, you can look at other statistics. Low doctor population ratio is very small compared to other nations and so on. So we all know all that. There's not much to belabor there. The point actually that always bothered me in all of this import business is a whole lot of these devices and materials are actually very low-hanging fruits. It's not rocket science at all, even though we've done very well in rocket science. So there's a little bit of a paradox here. The paradox is, well, stuff that we can actually really make, and it was shown in the time of COVID-19, as already pointed out, and I had a little ringside view of that during the COVID time, saying, look, it was so desperate when we started. We said there was nothing, no PPEs, nothing, right? Think about diagnostics and vaccines. Nobody was thinking about it. They said, can we really make it? Can we do it? Can we do it quickly enough? Can we do it with scale and quality? All of those questions were answered in affirmative. No doubt about it. So we know that the best of ventilators, best of everything could come up very, very quickly to the global standards. But why is it that we have such a big burden of imports when really it could be shown with examples that this is doable? What other countries might have taken 10 years to do, we could get there in 3 months. I mean, so this was really, really, I mean, it was a wake-up call. I said, look, there's something that we are not doing right in all of this, because there has to be something which is missing here. Now, of course, the future of medicine and healthcare is all about technology. Of course, that we live with technology today, but tomorrow that we would be forced to live with much greater scope of technology, which is going to impact every aspect of our life. So just, as a kind of keywords, we have germline genetic modifications all the way going, evolutionary enhancement, 3D printing. By the way, so just like the computation and information became really democratized, which means we have personal computers and personal computing in everybody's home. Similarly, of course, the manufacturing would also become distributed. And with the rise of 3D printing, there will really be making all this stuff at home, whether a shoe, for the right kind of shoe that fits my size and so on. And so that's going to impact, of course, the medtech sector in a big way. Biomimetic materials, which means taking lessons from nature and converting it into technology and products, is a very big, very exciting business. Antivirals, optogenetics, designer antibiotics, paper diagnostics, basically diagnostics that is inexpensive, that can be carried in everybody's pocket and can be used very easily. Robots, of course, robots for surgery, but also these tiny things which are sometimes thought of to be in the realm of science fiction. which means the little things running all over the body and doing diagnostics and fixing things and so on. A whole lot of things, actually what people regard as science fiction is going to come true for sure. So today's world and tomorrow's world is not limited by translation to a product or technology. It is limited only by ideas and imagination. And I'll give you some examples of that as we go. So always to remember that it is our inability to think big, it is our inability to think new and to take risk which are the roadblocks. It is not the technology. It is not translating an idea into a product. There are sometimes lights and shadows of technology, and so you fiddle with technology, but eventually it works. Of course, this discussion is not about, well, what could be the weaknesses and strengths of our medical systems, but just to kind of stuff that came to my mind. I was actually putting together these slides yesterday night after arriving here. And so I said, look, whatever comes to my head at that point, I put it, and I'm sure that all of you know this much better than I do, which is, the practicing doctors are now active researchers and collaborators, especially in medical materials and devices. And of course, Sree Chitra, which was set up for this purpose, is a very notable exception to that. But I have not seen this happen even in the great institutes of the country. So basically, people work in silos. And we know that by their training, by their culture, by their expectations, by their sense of peer recognition and who they're supposed to be, their sense of identity actually compels them to work in silos. And that happens, so biomedical research thrive in transdisciplinary ecosystem. Of course, this word has become very fashionable now: interdisciplinary, multidisciplinary, out-of-disciplinary, transdisciplinary, or no discipline at all, or whatever it is. No discipline at all could be a word that characterizes the society at large. But in this particular context, well, it basically means that joint appointments are difficult, inadequate research infrastructure, heavy patient load, which is really very unique to India. And so that's a problem. Medical professionals, very few, which take this up as a career option, and so on. So we know all of this, and we will probably know this for last 30 years, and we'll continue to know them for next 30 years. And so what is it that could be done? So let me just also introduce to you here that there is a new initiative in IIT Kanpur, where I sit, of making a world-class medical school and a hospital, driving inspiration from places like Harvard and MIT working together. Harvard doesn't have a great engineering school, but MIT does, which is right next door, and vice versa. So these guys working together are able to achieve so much. If you were to look at biomedical sector, biomed, products and devices and so on, I'll tell you a little bit more about it. Actually, I did visit, I know a lot of people in both of these places and actually how they work together. So this is a roadmap. Very little money is coming from the government, and this is to keep things flexible. In fact, we are raising about 1,000 crores from just alumni of IIT Kanpur. And so basically means that you can hire people at global salaries, if you would, and so have that flexibility with private money as a foundation. So this is going to be a new model. Let's see, that idea is that there is going to be more activities of the kind that Sree Chitra has been able to seed over the years and decades. So what really, I'll come back to that a little bit later perhaps. So what is it that one is looking for in all of this? Look, if you have a good engineering school in medicine and a lot of people working there, basic research, a lot of strengths, very deep strengths in basic research, medtech research, if you have a good incubation system and all that, what is really missing there is just a medical program. So if you can put in one more tile over there, of course it has to produce globally competitive doctors, that's the first thing. but the doctors, they have a little different kind of personality. In other words, that they are actively seeking collaborations with scientists and with engineers, and in fact, even with marketing people, with everybody else, to make it possible to take it to the market. I know Professor Ravi is sitting here, and he's a great expert in how to do all of this. So basic idea is, look, whenever I thought about it, I know this in the areas of, all the other products, not just biomedical products. The point is that we have separated knowledge creation from knowledge consumption. So this is a lot like our cultural aspect of worshipping Saraswati and Lakshmi as two different goddesses. But the fact is that while this separation may have some functional meaning, some operational meaning, you will get 2 holidays in place of 1, for example, worshipping different goddesses. But in the end of the day, they have to work together. They need to have respect for each other, which is a healthy respect, understanding of each other, and in fact, to do that for their own benefit. From what I know from the personality, Dr. Saraswat, I just pointed out that this oration, G. Parthasarathi Oration, G. Parthasarathi was the first VC of JNU. Of course, now you are the current Chancellor of JNU. So it's a small world across the history. So there are a whole lot of stuff which I already started in IIT Kanpur in that direction. For example, so these centers of excellence, each focusing on different aspects of technology as they relate to biomedical areas, telemedicine, AI applications, cardio and cancer, orthopedics, neuroscience, all the usual suspects where you would expect technology to play a great role there. And a lot of stuff is happening. So the very short point is, to give you an example, okay, this is a project Hriday Yantra, which is artificial heart, which is left ventricular assist device, LVAD, as they keep calling it. So I saw that there are about 20 people who are already working on this single project. And important aspect of that is that what do you need? You need a team which has mechanical engineers, electronic engineers, biomedical engineers, materials engineers, fluid mechanics of the highest kind that I have seen over here. So doing simulations about how this little blood is going to swirl around and how it's going to interact with the surfaces, what kind of shear is there, is it going to destroy, puncture red blood cells and so on. I mean, none of the other people actually can do that kind of stuff here. Biomaterials, what kind of surfaces, all kind of engineering, physics, plus industrial consultants, plus the whole innovation ecosystem that works with it, as well as the clinical and hospital collaborators. So this is the kind of stuff as a mission mode, if we were to identify certain devices. Of course, this is a little bit advanced. So this is going to take maybe about 2 years by the time it is delivered. I have seen many of these efforts, actually the same device, in maybe another 4 to 5 places in this country, who started to develop something like this half-heartedly, and after 6 months stopped. Or just made a bunch of tabletop stuff, but really were not very serious into taking it all the way to the market acceptability and to the global standards. That requires very substantial, focused effort by a very dedicated team of people. So I haven't any doubt that we would see this and several more things like this to be very success coming out from this team effort. Now, in biomedical materials and devices, there are different push and pull factors which are at play, and often these are same pull and push factors which are at play in science, technology in general. Some of these have already been talked about. Dr. Chandrasekhar talked about him. So what we see is we lack often the triple helix working together, which is the knowledge creators, R&D, clinicians, scientists, engineers, all giving their inputs in terms of knowledge, in terms of design, and so on. Then industry, nearby industry, including startups and markets, doing that together. And of course, the government in terms of policies and support, even as a buyer. Government often is a big time buyer. So to have that kind of support as well as policy, regulation and so on. We saw the power of this in COVID-19. And so one of the reasons that one could deliver so many devices quickly and with quality is because of triple helix working together. Of course, education, R&D in medicine in terms of culture, training, expectations, policies that empower, IP and patents, they used to be horribly slow in India. I mean, there were patents I filed 15 years ago and totally forgot about them. It's just now I know that some backlog is being cleared and the number of examiners have increased from 50 to 500. There's the first thing, I told Mr. Amitabh Kant when he was the secretary in DPIIT, he said, hey, you are a real scientist, right? You know what's wrong with us? What's wrong with you is you have no examiners, patent examiners. Secretaries may not often know what actually goes on right at the bottom of the pyramid. So he said, I'm going to fix this in 2 days. And maybe not 2 days, but anyway, things have been looking much better now. The target for IP should be about not more than a year and a half for sure from filing to granting. So I think hopefully move in that direction. A whole lot of stuff is happening in all of this. Things, regulations, regulators. Clinical studies are not always easy to do. I know so many people who ran out of the country to do clinical studies, even though I would have thought that this should be much easier to do for various reasons in the country. And of course, the standards. By the way, on standards and also like who should approve the medical devices, the best report I read was by Dr. Veliathan. This was in the 80s or 90s. So when we are looking at to see actually how biomedical devices are to be evaluated, the standards to be set up, would it be a distributed activity? Should there be a central regulatory body for it? And so on. All of these problems or questions were examined very critically by Dr. Veliathan and very good report there. Just to give you an example, okay, you saw what happened during COVID. We know that whole lot of stuff actually came out from Sree Chitra at that time. Used to communicate with a lot of scientists and director here at that time. By the way, I'm so greatly attached to Sree Chitra Institute. I will tell you in the lighter vein, I've read all the 300 mails and letters that came from here over nearly 7 years that I was in DST. So very, very good, connect with the institute and the activities which are going on here of many different kinds. So I've always felt very close to this institute, even though there are so many other institutes and so on. And this is because it really has shown, it has the potential and it has fulfilled a whole lot of that potential, and it can actually really rise to the occasion of delivering biomedical products and devices. So for example, this very good ventilator was made within 3 months in IIT Kanpur at the time of pandemic. Very interestingly, none of this ventilator this ventilator was actually acquired by the government. It was all acquired by private hospitals. So the reason I'm saying this is that there is some thinking which is needed about these problems, about procurement policies and so on, and a whole lot of other examples which are there. These examples only serve to reinforce our confidence and our faith in our system and the fact that there are basic strengths in that system. There are very deep strengths in that system. So let us look at where we are as a nation in science, in engineering, in technology. So good news is we are number 3 in number of scientific publications, and just about 9 years ago, we were 8, 9 in the number in terms of number of publications. So indeed, there has been a very quick rise in this number. And this includes actually the cutting edge in science, in engineering, in nano, in materials, in artificial intelligence, and also a number of startups in India. We are number 3, including the number of unicorns. Businesses with more than $1 billion worth of how you call it, the value, the worth of that enterprise. And of course, just 7, 8, 9 years ago, the whole question about startups was not heard of at all. In fact, about 12 years ago, I seeded a high-tech nanotechnology startup in IIT Kanpur. Nobody was willing to do it. I wrote my personal check, and I said, told my PhD student, if you fail, disappear with the check, and I will find you a position of some useless professor. That should be easy to do, right? But some people have to take, risk, and they have to convert their education and knowledge into new opportunities. And he did that, and he was so successful. But now, opportunities are multifold. So there never been a better time to be in a startup, to be an innovator than ever before. So there are deep strengths in R&D. Other words, there are strengths in creating new knowledge. Of course, the weakness I'll come to later, which is consuming this knowledge is a horrible weakness. So while we can create knowledge on demand, this is what I mean by deep strengths in R&D. And of course, it was pointed out, demography is a young nation. If I go to Lulu Mall, I am the oldest guy there, over 60 for sure. Okay, so it's a young nation, we know that. But this demographic dividend will become a demographic liability, as Dr. Chandrasekhar pointed out. If you were to look at the data, within 30 to 40 years, it's a graying of society, which means younger people supporting more, older people. I hate to use that word, older people. It just because I keep pointing out that there are no old people. There are only young people and younger people. Okay, so and they are not very different from each other at all. In any case, so new enabling policies are coming up, diversified markets, which means that if we can make a product that's successful in India, is going to find some market overseas somewhere, because every kind of market actually exists here and now. Okay, but the quality, for example, of our knowledge, our scientific publications, leaves something to be desired. So while we may be number 3 in number of papers, in quantity, in quality, it would be 10 to 12 to 15, depending on what quality parameters one looks at. Okay, and so that simply means that sometimes our research has no relevance and direction. So relevance and direction, they don't come from inside. They come from outside, which means they come from pull factor rather than push factor. Because most of the scientists are sitting, looking at over these great universities of the world, XYZ, what is it they are doing? So that becomes fashionable, and so therefore it becomes more incremental, it becomes more a following rather than being a leader. So in other words, relevance and direction being weak, it doesn't always connect with the market, doesn't always connect with the consumption of knowledge. Problem-centric is usually tool-centric, because education is tool-centric. It basically means, hey, if you were a chemistry major, they'll say, are you organic chemistry, inorganic, green chemistry, blue chemistry, red chemistry, something physical chemistry, all of that, so we define ourselves totally by this identity, which is horrible. It might have worked in the past a little bit. It might have worked in the past to get a particular job. But now to solve the big problems, the challenges of today and the future, it just doesn't work at all. I mean, people just get waylaid by their own definition of who they are, and not really be thinking holistically. So also it's important things about India being India-centric. Most of the science and scientists actually we have no connect with what's going on out there. We have direct connect with the scientific publications. Scientific publication is actually the best business in the world today, because really, somebody is paying the scientist, somebody is paying for the research. They write it up all dutifully. We write it up, and we submit it. They publish and make money. Okay, absolutely nothing else they have to do in all of this. So now, anyway, India-centric. What does it mean? Let's give an example. Everybody is worried about or is working on tools of artificial intelligence, machine learning, deep fake, anything that you can think about. But the point is, all of that research, including Industry 4.0, cyber physical, all of that has come from the nations who have no young people left. In other words, for them to keep growing economically, it cannot be through population. It has to be through machines. So the people they don't have, they substitute by machine, which are autonomous machines of Industry 4.0. so that the output, that industrial output keeps going up, and in a sense there is a economic growth. But the problem of India is just the opposite. So it's not that you want to replace people who are not there by machines. In fact, that one would want to do more with the help of machines that one is not able to do now. So while using the same technology, one has to use it in a different way. For reaching those people, we cannot now reach with the current technology, and at the same time enlarge the overall pie of the business. So, so the way somebody in Germany would think about machine learning and Industry 4.0 has to be completely different from the way that we think about it and deploy that technology. So whole point is that not a whole lot of us are actually doing that activity. So what we are doing is, look, if I'm a scientist, I know how to put together this machine learning algorithm and publish it, but that would be the end of it. Okay, let us very quickly look at what are a couple of overarching challenges of the future in science and technology. The first one, as I pointed out, rise of intelligent machines, which includes both algorithm and the physical entity that we call machine. So it's a convergence, first time in the history of science, convergence of materials, machines, communication, starting 5G and beyond, which is going to connect all the machines together, autonomous perception through sensors and by pulling in relevant information from internet, autonomous decision making, which is through machine learning tools, and then autonomous implementation of those actions, which is through actuators. So one can clearly see that everything is coming together. Industry 4.0 is a bundle of cyber and physical, digital and physical, and going to Industry 5.0, which is a little bit of future, would be integrating the biological in it, which means that all kind of scientists now find a challenge to come together. Other words, cyber and physical get into body, and also part of the body gets into cyber and physical, and both of that is happening on research level now, that until it becomes very widespread. So of course, what is happening in the digital cyber arena now and its convergence with the physical affects every aspect of our life. We already know that, whether it's learning skills of future education, work, governance. It's very interesting. I mean, we keep saying, look, we live in democracy. There are about 50 more countries that say they live in democracy. Each model of that democracy is very different from each other, even though there's a single word that describes a system of governance called democracy. If you were to dig deep into it, you see that each one of them have different strengths and weaknesses. And part of those strengths and weaknesses, in fact, are intimately related to what you may call information processing systems. Just to give you an example, sometimes what we call decentralized processing of information and action succeeds, and sometimes that is equated with democracy. And the reason it works is the same reason, because of which Roman Empire fell apart, is because of the fact that once it becomes very large, you cannot actually efficiently process information which is coming from far off places by a central entity and act on that in a distributed way. But imagine a future in which you can actually do that, which means that with the rise of intelligent machines and vast data processing capabilities, that actually you can centralized way process all that enormous information, make informed decisions based on that, and then have it acted in a distributed way. So that would change the model of governance in a very fundamental way. So similarly, judiciary, commerce, medicine, privacy, all of that are going to be impacted in a very fundamental way in the very, very basic fabric of our existence, if you would, doing that. So DST had launched a few missions which are related to these themes, and I have time to get into it. Let us look at the second overarching challenge of humanity, which is global, which is what is called sustainable development, sustainability, which is also related to climate aspects, and which is about, this is called complexity tax. Okay, there is no free lunch. So in fact, sometimes we were to look at it very closely, what it calls sustainable development, actually it's an oxymoron. So our concept about what is development is at odds with our concept about sustainability. And not any number of reports ever convinced me that the temperature rise by the end of this century would be less than 3 degrees Celsius. It would most likely exceed 3 degrees Celsius. And it's simply because, look, our concept of development is just this Chicago school at the turn of 20th century thinking, which says, look, that higher consumption basically means development. And there is no other alternative thinking which has actually gone into it or widely accepted. So that thing about, look, if I already have 3 cars, some society have average of 3 cars, then how am I going to develop in that direction, right? By adding 2 more cars, obviously, right? So that is a very strange concept. On the other hand, countries like India and society have very legitimate demands on what we call development, which is a different concept of development, if you would, which is related to what you call the base of the pyramid needs in the hierarchy of needs for human beings. So anyway, it's a complex thing, but I would just inject another dimension in it. So most of the scientists are thinking, look, if I made a little product or something, a technology, that would solve the problem of sustainable development or would contribute to it or would, would address climate change and so on. No, because these, first of all, these are global problems. Total interdependence, and then it has to deal with the lights and shadows of technology. It has to deal with the nexus of technology and the life cycle aspects of technology. What those means is that these are the issues which are bigger than an individual scientist. They are bigger than an individual lab. They are bigger than an individual institution. They are even bigger than an individual nation state. They may even be bigger than the humanity at large in the entire globe. This is sometimes, you get that feeling. But anyhow, this guy, I liked him a lot. He said he used to think the top environmental problems for biodiversity loss, ecosystem collapse, and climate change. I thought with 30 years of good science, we could address those problems. But he was wrong. The top environmental problems are selfishness, greed, and apathy. And to deal with those, we need a spiritual and cultural transformation. As was pointed out, spiritual then equate to religious. It just simply means a whole lot of things like empathy. It has to do with, look, what is our place in this world and so on. And he said, okay, he concludes, we scientists don't know how to do that. By the way, what he's saying about scientists is true for everybody in this whole society, right? So then the scientists are nothing, no special breed to worry about here. So point actually is that solving a problem through science and technology, it has multiple dimensions. The most important dimension being the cultural. Okay, and some of it is reflected in policy, in regulations, in rules, is what people obey or do not obey, and so on. And all of that, paying attention to all of that at an early stage is very helpful. Now, looking at, okay, let's say I just talked about 2 challenges, overarching challenges, because they are going to be touching every aspect of our lives. And no matter what kind of science I do, no matter what kind of medicine I do, finally, I would get plugged into one of these aspects somewhere, or that they would impact us in a very profound way. Now, so what kind of processes of mind actually are required to deal with these problems, which are holistic, which are big, which are multi-perspective, which are multi-dimensional, and so on, since we have fragmented our knowledge into so many different watertight compartments. So, okay, so clearly is the lateral thinking, creativity, common sense, Creativity is basically connecting those dots of knowledge which have not been connected before. In other words, that are people talking to people who are not like them. I never talk to chemical engineers. I have not done that for 30 years because I already know what they know, or I can learn about it on my own. There is no problem. But what a historian is doing or what an archaeologist does, I have no clue about it. But if I can understand their nomenclature, their way of thinking, perhaps my science can contribute to that. And so therefore open up a new perspective and a new domain, a new dimension of research. So connecting the dots which have not been connected before is the sense of creativity in the modern world. The scientific common sense, which is very uncommon. I don't know why we call it common sense. I give you my 30 years of teaching career. What I see is that common sense has become less and less and less, and it coincides with the rise of coaching classes. Obviously, as goes more, like they're correlated inversely with each other, um, and so on. So while, for example, National Education Policy 2020, it pays a lot of attention to being interdisciplinary, multidisciplinary, blah, blah, blah. But, I often end up yelling at IIT directors and saying, look, this is all lip service, no, because you're giving lectures, right? This is all lip service because if I give them a concrete example, my own PhD student, who has done better than all my PhD students, he has a permanent job in US. He wants to come back to India, but nobody would offer him a job. Why? Because he did his bachelor's in physics, a master's in material science, and PhD in chemical engineering. So we want to be truly interdisciplinary, multidisciplinary. Please hire this guy, right? Then people would say, oh, but department has to recommend him. So basic point is that we are so department centric in our hiring, firing, promotions, recognition, awards, everything, that the person's identity is totally tied to the undergraduate courses, the department that he serves in. In Hindi, in a crude way, they say, Radha mere aangan mein hi nachegi. Okay, it's not something easy to understand. But I say, look, only in my backyard, okay, my girlfriend has to stay in my backyard. Okay, it's a great sense of possession. And that is very psychological. Everybody thinks that they are the center, their discipline and their knowledge is the center of the universe. And everything else is really secondary. So that particular feeling is so deeply rooted in the culture of knowledge ecosystem, that it really requires effort to break it. Now, when I said creativity, lateral thinking, out-of-box thinking, and that's what is needed to do major advances, I want to give few examples, because this is, to make it a little bit concrete about what is it we are talking about. The first example is that of rise of atomic force microscopy, scanning, tunneling microscopy, which is what made all of nanotechnology possible. The modern nanotechnology is not based on some thought or theories. It is based on instruments that help you see at a small scales. This got a Nobel Prize. And these are also stories of more and more technology getting Nobel Prizes, and getting it very quickly. In good old days, one got a Nobel Prize when one leg is in academic grave, the other is maybe in the real one, 80 years later or something. But here, you start getting it 5 years later than the discovery. So, okay, now what is atomic force microscopy? So here we want to illustrate the power of ideas, about thinking differently. So when we think about seeing something, we think about light. That's a common experience. We think about maybe electron beam if you are a physicist or something. You think about radiation. But if you think about how does a blind person see, a visually challenged person, how does he or she see the world? Well, close your eyes, take a stick, walk around and poke it here, then you get a visual map or through that pressure on the stick. Same thing if you were to do on a small scale, which means take a micro stick, a micro cantilever like this, and tap it on the surface, then you'll be able to get a visual map which is on nanometer scale. And this is exactly what atomic force microscopy does. So question is, as I pointed out, usually the limiting factor in getting a good disruptive product is no longer technology, it is idea. So, just asking this idea, what are the different ways of seeing? I want to see something is not necessarily the light. It could be many other things. And then based on that concept of seeing, one can translate that into a reality. Second aspect of doing science and research, and this is true for everything that we do, this is because serendipity or chance plays a very big role in everything that we do, in discovery and so on, even though we don't acknowledge it. So often writing the paper is written in a linear logic. Everything is buried about all your frustrations, all your experiences, how things went wrong, how somebody just mentioned something, you picked it up and you got, everything is made to look like as if, he is a great genius guy who figured everything from beginning to end, in a very logical way. So presentations are logical, but the ways of science are non-linear, and they are, so point is, how do we acknowledge and leverage that particular aspect? And this is an example. So this is an example of rise of what is called graphene, which is a magic material which is used in electronics and everywhere else. Now graphene, how is it discovered? Graphene basically, for those of you don't know about it, is basically a single layer of carbon atoms. Like so all they are bonded together in this plane, but there's nothing above and below bonded to it. So a single layer of carbon atoms. Very, very useful material. And again, this is something that got a Nobel Prize in Physics in 2010. Now, okay, the way you can get graphene is by taking a block of graphite and putting a tape on its surface and then peeling it. So you remove, remove some carbon atoms here on the tape, and then because very low cohesion of carbon atoms in a graphitic block, so you can have a single layer of carbon atoms coming out on the peeling tape. Then you can examine it. Okay, the point is that the same experiment was being done for 60 years in different labs. But what they were doing this experiment to clean the surface of graphite so that you can examine graphite. So focus is on graphite, not on the tape. So you keep the block of graphite, throw away the tape. What these guys did, they threw away the block of graphite and kept the tape, right? So it's a question of where you focus. Okay, oftentimes, my students, PhD, other people, they come and say, sir, this experiment failed. I get totally alarmed. I say, how can experiment fail? There is no such thing. Experiment is the reality that we see. It cannot fail. It is your expectation from experiment that has failed. And those are the best of experiments where your expectation actually fails, because this is where you need to look very closely about what's really happening. So a theory or an expectation may fail, but an experiment cannot fail by definition. And so this is how we learn from serendipity. Third example, which is from my own group and lab at some point, which was fun. So this is why I presented. They look, we want to make some small objects with nanotechnology. You have to make nano objects, which may be three-dimensional, which may be complex. And question is, how do you make them? So there are like two paradigms, two ways of making a small thing. One of them is called top-down, which is using machine tools of different kinds, small things. You make something. Other one is called bottom-up approach, which is self-assembly, self-organization, maybe directed also. This is the way we are built. Everything in nature is built by self-assembly, which by the way is a very strong way of manufacturing, which slowly may come into human domain. Is saying, why don't we actually manufacture like the nature does? Very interesting subject. But anyhow, so we said, okay, bottom-up, not to be confused with bottoms-up. A lot of scientists even working in that area tell me they work in bottoms-up fabrication. I point out bottoms-up is taking an interesting substance in a glass, small glass, and pouring it in your mouth in one shot. That's totally different. Equally interesting though. Then, okay, so we said, look, is there a third way of manufacturing? Is there a third way of manufacturing other than top-down and bottom-up? We say, look, I saw this movie in the 80s. It was a popular movie called Honey, I Shrunk the Kids. Other words, if you have something big and if you can shrink it to small size, that could be another way to manufacture. Now, most people would just laugh at it. They say, what are you saying? Okay, very good, all right. But you see that we could, if you have this idea, you can always translate it into practice. And it got even published in Advanced Materials, which is the top journal of material science. A lot of people work 2-3 years with 5 PhD students to publish there. This took 2 weeks after you get the idea. Okay, so how do you do that? And it's fun. I mean, a whole lot of PhD students complain they are depressed. And I just don't understand how they are depressed and what's really going on there. I think they are taking this too seriously, this science, right? I mean, you have to take it seriously, but at the same time, you must have some excitement of what is really going on there. So the person is really jumping up and down with that excitement all the time, and this was one opportunity of that kind. So here is what you do. You take the object, make it, let's say 100 micron object, easy to make, then do a molding with a gel, which can be shrunk. So as you dry it, the gel will shrink, and then you mold it again and shrink it again, do it 5 times, you'll reduce dimensions by 1 order of magnitude. So therefore, any complex object, 3-dimensional object, can be made by shrinking the size. So it can be done. And so all I'm saying is, look, let's inspire people to do research which is exciting. which is fun, which is based on ideas. Because in today's world, I mean, everybody got tons, I mean, a whole lot of nations and, big universities. Let's say if you take the top 10 universities in the US, their research budget will exceed the budget of the Ministry of Science and Technology. So I say this just to give an idea about the scale of what we are talking about here. So, one cannot compete in a sense just by getting more resources. Of course, resources are needed, absolutely needed, no doubt about it. But what one has to compete on is the power of ideas that we often totally, ignore. We totally ignore them because they are not part of our education and training and culture. I mean, can you imagine a person who would be creative, do lateral thinking, out-of-box ideas, and even pass his high school exam? Impossible. Certainly would not crack a JEE or any exam of that kind by that route. So that's what it is. Okay, there's some examples of taking inspiration from nature, which is a storehouse of wonderful technologies, and by understanding it and converting into products and technology, one can do a lot. There are some very simple examples, which all come from nature, and saying how do we make water repellent paints, as in the lotus? How do we make these vibrant colors that you see in nature? None of my cars actually shine like that. I mean, like a butterfly wing or this peacock feather, right? So at the same time, it's also a storehouse for very deep scientific knowledge. So why do we have these vibrant colors? Because the color is not coming from a pigment. So there is a very good optical physics in it. So while understanding that physics and then translating that into a product or technology is such a wonderful thing, and more of it would happen in the future. Thinking of the future, I say, look, how do you engineer, how do you predict the future? Of course, there is no predicting the future. I mean, nobody would have predicted 40 years ago the cell phones and everything else that we carry, the internet, the emails and whatever. I remember the first email exchange I had was back in '82. It was an experimental system between few US universities. So I was sitting in this one room. I'm talking to my old IIT Kanpur friend. He is sitting in Carnegie Mellon. I'm sitting in Penn State. I type something, immediately gets and replies. I remember that afternoon and excitement so well. I said, great. I thought this is going to simplify my life. 40 years later, I couldn't have been more wrong. So anyhow, you cannot see the future. And then they come back to the lights and shadows of technology. Let me just give a very quick example. That even those people who have worked 40 years at the apex of a sector cannot predict the future. In fact, this great company in the US who are pioneers of personal computers and personal computing, and their top leadership opined that it has no future. And there was, at the same time, there was another company which were into photography. All of us who grew up, there was only one photography company in the whole world. And we all, grew up with that. And they were pioneers of digital photography also. But their top leadership opined that digital photography has no future. And in fact, the company itself had no future. It disappeared within 1 decade. So, you often think about how could these guys be so horribly wrong? I mean, after all, these are the guys who should know because they've been in that business for 4 decades. The reason was very simple as to why both of these companies did not anticipate the future. Because you think about it, see, personal computer and personal computing like Windows and stuff, they will have no future unless you have digital applications to run at home. Digital application like digital photography will have no future unless you have a PC sitting at home. So these two are what you may call interdependent businesses of technology. They are in the proximal areas of each other. So unless I knew what was actually happening around me, I would not be able to decide about my own sector. Obviously, that would be a very limited perspective. And this is what can go wrong by being not connected. There was a Vision 2020 in technology, which was put together under the chairmanship of Dr. Abdul Kalam. And then, of course, there's again another small world. So you see Dr. Saraswat sitting here. He's the chairman of TIFAC, who have put together Vision 2020, and now is there another Vision 2035. So if you want to learn about what might be happening in terms of some products and expectations for technology of the future, this is a good report to start with, and this is downloadable, so it's free to access. There are also another sectoral reports like transport, energy, water, health, blah, 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 and what kind of technological roadmap would actually be coming up in all of those. And those are all available on the TIFAC thing. So think about processes of science and technology and the new mind, which has to be able to do all of this. A shift from tool-centric to problem-centric. Other words, saying, look, I am an expert in that, so I will find a problem where my tool matches the problem or some aspect of problem. This is a lot like there was a little story I read in high school. I always remember that, and that is so interesting. There was this guy, Mullah Nasruddin, the wise man of the East. So he lost a bunch of keys, and he's searching for them for 4 hours, can't find them. Then his friend came and joined him in the search. Another 2 hours, and he said, Mullah, where did you lose your bunch of keys? He said, why? I lost them there. So he said, then why are you searching here? He says, because there is more light here. Yeah. So it's basically all of us do what actually is easy to do, convenient to do, what matches my resources, rather than what needs to be done, even though it may be harder to do that. And so I think there's a very strong lesson in science in doing all sorts of things that we do. Okay. Now, final thing about invention to innovation, or knowledge generation to knowledge consumption. So this is something, of course, doctors are by definition here. So in clinicians, they are consumers of knowledge. So they transmit knowledge and they consume it. But a whole lot of scientific research is not like that. So essentially, you are generators of knowledge, you are creators of knowledge, and also you are transmitting that knowledge to students. But there is no mechanism for consuming that knowledge. That mechanism for consuming the knowledge comes from outside. So therefore, oftentimes, when I was in Delhi, Dr. Saraswati is here. So when I was in Delhi, everybody said, our science is very weak, no? Right? And I never understood what they mean by our science being weak. Actually, our science is not weak. The creation of scientific knowledge is not weak. It is the consumption of scientific knowledge which is a weak link. So the reason this is important to be said is because otherwise you would be barking up the wrong tree. In other words, you would just say, look, if only I increase the budget for R&D, problems would be solved. Of course, you need to increase budget for R&D. That's a separate problem. But the problem is not necessarily the solution, is not simply increasing the budget for R&D. It is how that R&D gets translated into fruits of R&D. And that requires a complete different ecosystem and different set of problems to be addressed. How much time do I have left? Any idea about here? We are already running late, no? What? That's a very dangerous thing to say, huh? Okay. The last time somebody said it, I continued for 3.5 hours. So I must caution you. But anyhow, I'll try my best to wrap it up very quickly. So we are talking about interdisciplinary, multidisciplinary, and so on. And this is because we said there are so many programs, of this. To my mind, I thought about it. I said, look, all of science and engineering can be organized under 4 M's. They are not this chemistry, that physics, that engineering, something. They are basically mechanics, which is the understanding, materials, machines, which is the final form of what you make out of understanding and materials, and then manufacturing it. And of course, 3 other M's which scientists don't like to acknowledge are markets, money, and men. Okay, so these are the most critical aspects of doing science and technology. It doesn't matter if I call myself organic chemist or what I call myself, right? All of that has meaning, because when I walk into a meeting, everybody else there is an organic chemist, so I know all of them, and I know I can get some grant from there if I have some friends there. But beyond that, it has very little meaning about what I call myself. I don't have time to get into it, but I just want to point out that, look, what we consider, let us say, medicine today, science today, technology today, all of that is intimately related to the forms of industry, the nature of industry. The nature of society is dictated by the nature of industry. And this can be, I mean, the whole thing can be proved by looking at various industrial revolutions, going from industry 0 to 1 to 2 to 3 to now we are into industry 4.0, and how we will then graduate into industry 5.0. Will definitely, the contours of that society will completely change. The way you dispense justice, the way you dispense medicine, all systems of knowledge actually adopt to that particular aspect. No time to get into it, but to say, okay, let's go into invention and their relation to innovation. Innovation is a word which is really not understood by a whole lot of scientists. Okay, it's just people think that a very good invention is innovation. Say if it's very creative, it's innovation, innovative thought. No, and nothing to do with it. Invention we understand very well. Invention and discovery we understand very well, but not innovation. In fact, about 12 years ago, there was a CSIR committee to make a Bhatnagar Award in innovation. I was a member of that. After 3 meetings, none of the members could not decide on what is innovation. And therefore, they said, how will we judge it? What are we quantified? By the way, judging and quantifying innovation is in fact easier than quantifying invention. And I'll tell you why. Because the concept of innovation and invention is like this. If we think about a black box, in the invention, money and resources flow in and knowledge flows out. That's invention. Innovation is opposite of that. Mathematically, it's orthogonal to processes of invention. In other words, here's a black box of innovation in which knowledge flows in and money flows out. Okay, so unless it has economic impact, that thought is not innovative thought, no matter how creative it is. In other words, it's not going to have impact on economic indices if it's not going to create new socio-economic opportunities based on that knowledge, then it is not innovation. So therefore, invention and innovation working together complete the circle of knowledge. So if the knowledge were to be sustainable, it means that knowledge has to be created and also consumed to create more money that creates more knowledge, and all the great societies that flourish are basically because of the Jugalbandi, the symphony of invention and innovation working together. Okay, I'll skip all that. Of course, like I pointed out, that through policies, one can enable working of science. So science often is shackled. It cannot come into play fully unless there are enabling tools and policies. So there have been a lot of policies going on. Very soon, Dr. Chandrasekhar has said that new policy would be coming out for science, technology, and innovation. When it started, it was called STIP 2020. Then I changed to STIP 2021. Maybe 22, maybe 23, but anyway, it's going to be out. Would be a nice tool there. Okay, so now we started saying, look, can we say about future? We said, look, we can't really say very much about the future, but we can say about the directions of future. And those directions of future are dictated by the desires of mind. So in other words, what are those deep driving desires of mind that create new technology, that create new opportunities and so on, and that tells us about the future. So to be healthy, to have good quality of life, to be connected with equality, and the rise of social media, for example, is in response to that need to learn and to apply, to make decisions in complexity. The rise of AI, ML, all that is in response to that need to be entertained, to have better life, to be happy, to find fulfillment, to create and control its own world. For example, the rise of virtual reality, augmented reality, mixed reality, parallel reality, all of that, which is going to become very much more pervasive. I mean, I guarantee you that 40 years from now, it will not be like this. All of our avatars would actually be interacting with each other. That world is not very far, and not as much far as we think it might be. So in other words, even the sensations that we get by physically being together could be simulated through these alternate versions of reality. Reality is nothing but the sensory perception. Whether we call it physical, the only reason we differentiate between, let's say, a Zoom meeting and this meeting is because both of them are images, except that that image is a little flat. Okay, and it didn't do justice to all the senses that, I can't engage all my senses there. But once that is figured out, then, wow, there's no difference between this reality and that reality or version. So this is actually not just science fiction. What I'm saying is a whole lot of Industry 4.0 now works on creating clones or avatars or digital twins, which, mimic the behavior of the original system or the machine. So therefore, there one can understand them much better. Of course, to live long, maybe forever, is certainly going to create new set of technologies, not only for physical, in the medicine area, which is happening, genes, level of genes and so on, but in digital level. So imagine if all of our experiences were kept and downloaded to an entity which is then driven by artificial intelligence, which lives forever. So otherwise, it's not a static entity which has all the experiences, but it's continuously gaining new information and perception, and therefore growing. So imagine if you were to interact with Mahatma Gandhi today or his avatar. I mean, I'm sure that many of his opinions might have been adjusted or have evolved. So it's not a fossilized persona anymore, right? It's a learning, growing person in terms of the mental processes. Okay, so I think this may be last few slides. Now, when you look at the larger picture of where science and technology is going to take us, this is something I learned in Psychology 101 in 1977. And this is Maslow's pyramid of hierarchical needs. The needs at the bottom, they are called deficiency needs. Roti, kapda, makan, start physiological needs, safety needs, belonging and love, and having some esteem, including self-esteem. Okay, so all of these needs, you see, are very strongly addressable by science and technology solutions. In fact, this is what we work on all the time. But at the same time, if you were to look at other needs, once you have, even what we call affluent societies and so on, they have in some ways, you think, have addressed these needs, or even, look at some people in our societies, also they have satisfied these needs more or less. But now you move up, which is say growth needs, cognitive needs, aesthetic needs, self-actualization, transcendence. There is not a pyramid made by some Rishi Muni. This is coming from Western research or recognized things. So obviously we know that these are needs that we need to satisfy. But interestingly, you would also recognize that those needs are not easily addressable by current tools of science and technology. In fact, they may even have inverse relation. I have seen a lot of very rich people, all secure in roti, kapda, makan, but not secure at all in the other needs. They totally ignore aesthetic needs. They say, they're just too busy making money or something like that, and all this stuff, right? So interestingly, you see ancient Indian societies actually paid a lot of attention to those needs starting from cognitive and up. However, of late, they may have ignored the base needs. Other words, even need for security. How can, you lose a battle, right? If you lose a battle, you have no possibility of satisfying the higher needs ever, right? So it is a balance between the needs of external world and the needs of internal world. A balance between them is what makes for a happy society. And I think that this is something maybe we have not, transmitting in a very strong way in school and college education. That, I think this indeed is the last slide. And this may be interesting because there's a song and dance in it, song and dance. So the background is like that of the song and dance. This is about injecting some fun and excitement in research, as I pointed out, and learning from everyday occurrence about our deep research. So for 20 years or so, my group has been working on self-assembly of polymer dots. I would like to think that we have been a leading group in the world in that particular area of self-assembly. And indeed, they were able to do great things. Like all of these polymer domains that you see here, transparent material, but it's self-assembled. So it is not made with a machine, but it's made the way it happens in nature. But then, when you make these structures, then you say, what do I do with them, right? How do I find an application for it, and so on. And indeed, there are many, many compelling applications. I just want to give you one example of how we came across one application of this array of polymer dots. Each of these dots is a micro scale lens, or it could be nanoscale lens. And what do we do with an array of micro or nano lenses? Was the question. So if you play this clip, please, 30 seconds, and then we are done. Who's doing? Can you hit the? Somebody has a copyright on this, so if I embed it in my PPTs, they remove it from YouTube. So sometimes people put this lecture or some other lecture with this on YouTube, then they remove it. They say, hey, this is copyright protected or something. Yeah, what happened? No, just play it. Only 30 seconds, yeah. Just go ahead, play it. So you can either see or hear, but not together. Okay, if you can't do it together, forget the song, just go for dance. Oh, chup to gaya. Oh, nothing coming here, you can't see. Just play what you were doing earlier, forget the sound. Okay, anyhow, if we can't, the reason I wanted to play this is just, first of all, you feel a little relaxed, after all this science wine talk kind of stuff after 1 hour, right? You say, oh, this looks good. And the fact is that you can get inspiration from everything that we see, whether it is a movie, whether it's a plant, whether it is anything. So here in this particular song, how many people here remember seeing it? This is from a movie called Mughal-e-Azam. Mughal-e-Azam, nobody has seen? Oh my God, only a few people have seen it. Oh, what a beautiful movie. And it's with color. This was the first color sequence in Bollywood movies, this dance. And then, so it basically shows an array of mirrors in this palace, and the Madhubala is dancing, and you make small copies of Madhubala in all of these mirrors, right? So essentially that if you want to do, let's say, want to do micro nano fabrication of a complex object, you take that complex object, shine them through this array of polymer lenses that I had shown, then you would make a small copy of that complex object in all of these mirrors or lenses, and you can put another photosensitive material behind this array of lenses, so that small copies of Madhubala, large number of them, like nanoscale, are printed on this material. This is called photolithography. So you can make, you can do photolithography with this array of lenses, which was self-assembled. Okay, so just as an inspiration. Okay, so I think forget about that. Let's just go back to the last slide, the conclusion. Actually, it had a couple of messages, this movie for me, and the overarching message was, take risk even if you have to fail. It's better to have loved and lost than not to have loved at all. Okay, and this is actually a message for young scientists. So because we do things that we know we can do. I mean, most of the project proposals that come to DST, they know that they've already been done. I mean, they only have to put some data which would be acquired, right? This is, I mean, who are we trying to satisfy here? Okay, I mean, the whole point is the world doesn't care how many papers written. Sometimes I look back and say I wrote 80 papers, but maybe if I wrote only 80, would have been much better, would have saved me time. I mean, for, writing things which are not of great quality. And at the same time, we would have more time, energy for doing things which are more sensible, right? So this movie is a little bit about that, having courage, having the confidence to even chase little impossible dreams. And the second aspect, of course, which is more trivial, is like how to make use of array of lenses for technology purposes. Okay, I go back to the what we call presentation, the PPT, and the last slide there. But it's pretty much over anyway. I mean, last slide maybe is some kind of conclusion somewhere. Okay. Future is about convergence, drivers and directions of technology, and understanding minds, needs, demands, wants, desires, and greed. Not all demands can be fulfilled with technology alone. So therefore need a balancing act. There are lights and shadows of technology, and they are reflected in nexus and life cycle analysis, which requires actually a larger system to understand and work on technology. Usually, technology are developed by a corporation, by one group and so on, but they don't have a holistic feel of how it's going to impact, right? Everything has an impact. For example, when you work about Nexus, you say, look, I can't really think about water without thinking about agriculture, because 75% water is used in agriculture. In fact, I'll give you one last example and then leave, which is, that there was this great invention which was being proposed for funding, which is to have a very much more efficient solar pump, which draws water from much greater depth. As we know that groundwater is declining very alarmingly, and it is driven by solar power. So what can be a better technology solution than this? We should fund it, right? No, we should not fund it. And with great difficulty, I had to convince other people not to fund it, right? Because here is a free power. There are big, vast lands which are being done with flood irrigation, and now you can get water more efficiently out from down there, for which you are not paying anything, neither for water nor for power. And with the ease of using all this, where the water is going to go, right? So instead of switching to drip irrigation, people are just going to continue with flood irrigation. If you give them better technology to exploit environment even better, right? This is the principal reason because of which technological interventions are not very successful in taking care of larger problems like that of climate change and so on, because technology only targets greater efficiency, but it does not target, it targets greater efficiency per GDP, but the GDP keeps on increasing. In other words, the consumption, and some of it very unwanted, unrecycled consumption, keeps on increasing. So since there are no bounds on that, even if you increase the efficiency of technology, it then solves the problem. Now, of course, a lot of these people worked with me at different times, and I'm very grateful for some of the scientific stuff that I had shown there. And okay, so that's the end. Thank you so very much.
Thank you, sir, for your enlightening words. I now invite Dr. Hari Krishna Verma, Head Biomedical Technology Wing, to kindly propose the vote of thanks.
Padma Bhushan Dr. V.K. Sarath, the Honorable President of the Institute, who is presided over this August function. Chief Guest Sri V. Muralidharan, Honorable Minister for State for External Affairs and Parliamentary Affairs. Professor S. Chandrasekhar, Secretary of Government of India, Department of Science and Technology. Professor Atul Goyal, Director General of Health Services, Government of India. Professor Ashutosh Sharma, former DST Secretary and Professor of IIT Kanpur, and today's Speaker, and Professor Sanjay Bihari, the Honorable Director of the Institute, Professor V.K. Ajit Kumar, the Dean of the Institute, Professor Keshav Das, and my dear distinguished guests, esteemed colleagues, ladies and gentlemen. It's a proud moment for us to part of these two major events, and that is the inauguration of Chitra Conclave and G. Parthasarathi Oration. The Chitra Conclave is the fourth episode of the technology of this institute, and it's an event in another milestone in the history of the institute to celebrate and re-emphasize the need of importance of indigenous technology development, especially in the area of medical devices. So now it's my time to express our relentless gratitude and place on record our vote of thanks to the galaxy of eminent personality who joins us today for this event. Our Honorable President of the Institute, Dr. V.K. Saraswat, has been a great source of inspiration and guide for the Institute's program since the day he assumed the office charge. As a towering personality from the scientific fraternity of our country, he is the person who constantly interacts with us and guides us. Today, he emphasized the need of interaction and engagement of the industry from the early phase and the importance of knowledge-based product development. On behalf of the Institute, I express heartfelt thanks to you, sir, for the presiding of the function and enlightening us with your inspiring words. Thank you, sir. Our chief host to function, Sri V. Muralidharan Ji, the Honorable Minister of the State for External Affairs and Parliamentary Affairs, is a great well-wisher of our institute and always been kind and extend his helping hands all over our development of the institute. Today he has mentioned about the Atmanirbhar Bharat and as well as the importance of affordable healthcare to the masses. So we are very grateful to Professor Sri Muralidharan Ji and on behalf of the institute and Chitra family, let me express our heartfelt thanks. Professor S. Chandrasekhar, Secretary to Government of India and Department of Science and Technology, is also our midst to and felicitated with a special address. The importance of product development with international standards, which meets not in India-centric, but to the global, and the importance of the aging population and when we reach 2047. And also, he very importantly point out the importance of raw materials, which should be available, then only we'll go further. On behalf of the Institute, let me express our heartfelt thanks to you, sir, and thank you very much, sir, for your maiden visit to the Institute. Professor Atul Goyal, the Director General of the Health Service, Government of India, who is also the esteemed member of our Institute body and governing body, also with us today in enlightenment. And importantly, he has specifically mentioned about the disease burden and the prevention of such diseases, which is when we are getting age, as well as although the generic use of the generic medicines, which is also very important. Thank you very much, sir. We are really honored, Professor, by Professor Ashutosh Sharma's presence here, and he really, without having any pigments, without having any, just like in the case of a peacock feather, he fulfilled our minds with the colors and the thought-provoking lecture, and we are extremely thankful to you, sir. So on our institute, I thank all being today and the motivating us with this very inspirational and different speech. Thank you very much, sir. Sri C. Padmakumar, Special Officer of Kerala Medical Technology Consortium. He was always with us for the programs and he even helped us to organize it with a lot of enthusiasm and difference. So thank you very much, sir. And Professor Sanjay Bihari, the Honorable Director of the Institute, is leading as our captain in all our activities. And we are, this is only the beginning, and we are going to witness many, many such new and totally disruptive engagements in the coming days. And sir, all your valuable suggestions and utilizing your efforts has made today's event remarkable. Thank you, sir, for this. I also thank Professor Ajit Kumar, the Dean of the Institute and Deputy Director, Professor C. Kechav, for all the supports during this organization of this function. And on behalf of the Institute, I thank the distinguished guests, and pardon me for not naming everybody, and including the Institute body and governing body members, so Dr. T.P. Senkumar, and all the dignitaries who was with us and making this one a very memorable one. Thank you all, sir. I'm also expressing our thanks to the media as well as all the departments, who was with us today and for the last maybe a month to making this one happen. And I am thankful to each and every member of the Chitra family for making this happen. And once again, thank you all. And if I missed anybody, pardon me for that. But once again, thank you everybody, each one members of the students and those who are coming far away from the places. And once again, thank you. Jai Hind.
Thank you, sir. May I now request our Honorable President, Dr. V.K. Saraswat, Secretary, Department of Science and Technology, Professor S. Chandrasekhar, our Honorable Director, Professor Sanjay Bihari, Special Officer, Kerala Medical Technology Consortium, Sri C. Padmakumar, Dean of SETIMST, Professor Ajit Kumar V.K., Deputy Director of SETIMST, Professor C. Keshav, and Head of BMT Wing, Dr. Harikrishna Varma, to kindly come on to the dais to felicitate our esteemed orator, Professor Ashutosh Sharma, and to be kindly seated on the dais. I also kindly invite our esteemed orator, Professor Ashutosh Sharma, to come on the dais. So may I kindly request our esteemed dignitaries to be seated on the dais, please? Thank you, dignitaries. It is now time to close the function. May I now kindly request the gathering to rise for the national anthem. Ladies and gentlemen, we have now come to the end of the function. We cordially invite you all to join us for tea and the Sree Chitra Conclave 2022 proceedings hereafter. Have a pleasant afternoon.